Hello students, today we are going to discuss on the topic water as a biological solvent. Now coming to introduction, water is the most important substance of life. It also provides an environment for many species. All cells contain a minimum of 85% of water, with most fluids inside and outside of the cells likely to have at least 90% water. Both transportation of molecules and chemical reactions takes place in dissolved water. Water acts as a metabolite in many reactions, either as a reactant or as a product of a reaction. It is involved in many reactions like photosynthesis, digestion, and aerobic respiration. A wide range of biomolecules are dissolved in water, including sugars, amino acids, small nucleic acids, and proteins. Only non-polar lipids and large polymers like polysaccharides, large proteins do not dissolve. Cells host a huge range of chemical reactions. Many of these are catalyzed by enzymes. Enzyme activity is sensitive to temperature, and reactions only occur in a narrow range of temperatures. Water helps to buffer temperature changes because of its relative high specific heat capacity. It also helps transport dissolved compounds into and out of cells. Almost all biological macromolecules, proteins, and DNAs are inactive in the absence of water. Hydration of a protein is particularly important for the stability of the structure and for the function, especially the recognition at a specific site. So, water is the solvent of the body and it regulates all functions, including the activity of everything it dissolves and circulates. Now coming to water as a biological solvent. Water is a versatile solvent due to its polarity, which allows it to form hydrogen bonds easily. When an ionic compound is dissolved in water, each ion is surrounded by a sphere of water molecules called a hydration shell. Water dissolves inorganic and organic compounds alike, simultaneously serving as both good and poor solvent for biological macromolecules such as proteins, those with molecular weight in excess of 10 to the power 6 gram per mole. Blood is an example of proteinaceous milieu containing 0.1 molar sodium chloride with a wide variety of proteins. On the other hand, water is a rather poor solvent for nonpolar macromolecules. This is largely responsible for the self-assembly of lipids into the bilayer structure, building blocks of living cells. Otherwise, lipids would dissolve in water, failing to organize into any entity whatsoever, and proteins would not form the secondary or tertiary structures so essential to, say, enzyme activity. The peculiar feature of this sparing hydrocarbon solubility in water is that it is temperature independent. If this were not the case, a slight change in temperature would cause water to become a more aggressive solvent, possibly corroding life by dissolving lipid and protein assemblies. Now coming to weak acid and bases. Weak acids and bases are ubiquitous in biological system and play important roles in metabolism and its regulation. A weak acid is an acid that do not dissociate completely, releasing only some of its hydrogen atoms into the solution. The majority of acids are weak. On average, only about 1% of a weak acid solution dissociates in water in a 0.1 mole per liter solution. Therefore, the concentration of hydrogen ions in a weak acid solution is always less than the concentration of the undissociated species. Thus, it is less capable than strong acids at donating protons. Weak acids have very small values for Ka and therefore higher values of pKa compared to strong acids, which have very large Ka values and slightly negative pKa values. Now, examples of weak acids include acetic acid, phosphoric acid, and oxalic acid. The strength of a weak acid is represented as an equilibrium constant or as a percent dissociation. The equilibrium concentration of reactants and products are related by the acid dissociation constant expression, Ka. The greater value of Ka, the more the formation of hydrogen ion is favored, and the lower the pH of the solution. The Ka of weak acid varies between acids with Ka less than 1.8 into 10 to the power minus 16 are weaker acid than water. A weak base is a chemical base that does not ionize fully in an aqueous solution. This results in a relatively low pH compared to strong base. Weak bases do not completely dissociate at equilibrium in water. So, calculating the pH of this solution requires consideration of a unique ionization constant and equilibrium concentration. Now coming to the relationship between Ka and Kb. When acid strength increases, conjugate base strength decreases, and base strength increases, conjugate acid strength decreases. This relationship can be illustrated mathematically using the Ka and Kb expressions for a conjugate acid-base pairs. Weak acid IceA plus water gives A negative plus ICE3O plus. Ka is equal to concentration of ICE3O plus into concentration of A negative divided by concentration of IceA. Conjugate base A negative plus water gives IceA plus O ice negative. Kb is equal to concentration of IceA into concentration of O ice negative divided by concentration of A negative. Multiplying the two equilibrium expression and simplifying gives Ka into Kb is equal to concentration of ICE3O plus into concentration of A negative divided by concentration of IceA into concentration of IceA into concentration of O ice negative divided by concentration of A negative. It becomes Ka into Kb is equal to concentration of ICE3O plus into concentration of O ice negative. Therefore, Ka into Kb is equal to Kw, which is equal to 1 into 10 to the power minus 14 at 25 degrees Celsius. Notice that as Ka increases, acid strength increases and Kb for the conjugate base must decrease. Thus, stronger acids have weak conjugate bases and stronger bases have weak conjugate acids. This relationship can be used to determine, for example, the Kb for weak base if the Ka for the conjugate acid is known. Now coming to pH. pH is the measurement of hydrogen ion concentration. pH may be defined as the negative logarithm of the hydrogen ion concentration, or pH of the solution is the logarithm of the reciprocal of hydrogen ion concentration. This definition of pH was introduced by the Danish biochemist Søren Peter in 1909. Every aqueous solution can be measured determine its pH value. This value ranges from 0 to 14 pH. pH 7 is the center of the measurement scale. It is neither acidic or basic. It is called nutrient pH. Measurement of pH is one of the most important and frequently used procedure in biochemistry. Almost all processes containing water have a need for pH measurement. Most living things depend on a proper pH level to sustain life. The pH affects the structure and activity of biological macromolecules. For example, the catalytic activity of enzymes is strongly dependent on pH. All human beings and animals rely on internal mechanism to maintain the pH level of their blood. The blood flowing through our veins must have a pH between 7.35 and 7.45. Exceeding this range by as little as 1/10 of a pH unit could prove fatal. It is expressed mathematically as pH is equal to negative log of hydrogen ion concentration. Hydrogen ions concentration is expressed in terms of mole per liter. The pH value is an expression of the ratio of hydrogen ion concentration to hydroxide ion concentration. Hence, if the hydrogen ion concentration is greater than hydrogen ion concentration, the solution is acidic. Conversely, if the hydroxide ion is greater than hydrogen expression of the ratio of hydrogen ion concentration to hydroxide ion concentration. Hence, if the hydrogen ion concentration is greater than hydrogen ion concentration, the solution is acidic. Conversely, if the hydroxide ion is greater than hydrogen ion concentration, the solution is basic. At pH 7, the ratio of hydrogen ion to hydroxide ion is equal, and therefore the solution is neutral. As shown in the equation below, pH is a logarithmic function. A change of 1 pH unit represents a 10-fold change in concentration of hydrogen ion. Now coming to pH scale. pH scale is used to describe whether a solution is acidic or basic. The pH scale designates the hydrogen ion and hydroxyl ion concentration. The ion product of water is the basis for the pH scale. As mentioned above, that pH is equal to negative log of hydrogen ion concentration. The pH scale is logarithmic. If two solutions differ in pH by 1 pH unit, then one solution has 10 times the hydrogen concentration of the other. It does not tell us the absolute magnitude of the difference. Now coming to ways of measuring pH. pH is in an aqueous solution can be measured in a variety of ways. The most common way uses a pH-sensitive electrode, a reference electrode, and a pH meter. Alternative methods for determining the pH of a solution are indicators. Indicators are materials that are specifically designed to change color when exposed to different pH values. The color of a weighted sample paper is matched to a color on a colored chart to infer a pH value. pH paper is available for narrow pH ranges and fairly wide pH ranges of 1 to 11. Now, colorimeter. This device uses a vial filled with an appropriate volume of sample to which a reagent is added. As the reagent is added, a color change takes place. The color of this solution is then compared to a color wheel or spectral standard to interpolate the pH value. The colorimeter can be used for graph sample measuring, but not for continuous online measuring. Typically used to determine the pH value of water in swimming pools, spas, cooling towers, and boilers and river waters. Now coming to conclusion. The essentiality of water for living system is quite evident, as without water there is no life. It was in water that the chemical reactions of biological processes evolved. All aspects of cell structure and function are adapted to the physical and chemical properties of water. The strong attractive forces between water molecules result in water's solvent properties. The water molecule and its ionization products greatly influence the structure, assemblies, and properties of all the cellular components, including enzymes and other proteins, nucleic acids, and lipids. Water is needed not only for biochemical reactions, but also for transporting substances across membranes, maintaining body temperature, dissolving waste products for excretion, and producing digestive fluids. Water is the medium in which the first cell arose, and the solvent in which most biochemical transformations takes place. The properties of water have set the course of evolution and exert a decisive influence on the structure of biomolecules in aqueous solution. Many of the interactions within and between biomolecules are strongly influenced by the solvent properties of water.
Dear students, a very warm welcome to all of you. Today we will discuss the topic reproduction in bacteria. Bacteria are small microscopic prokaryotic organisms which lack a nuclear membrane and other membrane-bound organelles like mitochondria and chloroplasts. Bacteria have always attracted the attention of human mind owing to their tremendous biological and ecological significance. They are very abundant in nature, and the secret of their abundance lies in their splendid way of reproduction. Bacteria are generally known to reproduce by asexual reproduction. True sexual reproduction is absent in bacteria, but genetic recombination takes place through conjugation, transduction, and transformation. Asexual reproduction in bacteria, including the gram-negative of photosynthetic cyanobacteria, takes place by following methods. The first type of asexual reproduction in bacteria is binary fission. This is the most common type of asexual reproduction in actually growing bacteria, and it occurs under favorable conditions. In this case, a single bacterial cell divides equally into two identical daughter cells. The whole process of binary fission involves two steps: genome replication and septum formation. In gene, the genome in DNA replicates into two daughter DNA molecules. The two daughter DNA molecules segregate, which is followed by septum formation and ultimately the formation of two nearly equal daughter cells. The whole process is very quick, and it takes about 20 to 30 minutes. Thus, a single bacteria may give rise to millions of bacteria in just a few hours. The second type of asexual reproduction in bacteria is gonidia formation. The parent cell produces a number of flagellated daughter cells within. These daughter cells are also called as swarmers. The cell wall of the parent cell ruptures, releasing gonidia. The third type of asexual reproduction in bacteria is the conidia formation. It occurs in mycelial bacteria. The terminal portions of the bacterial filaments cut off rounded structures continuously in chains. These are called as conidia. The conidia on detachment form new individuals. The next type of asexual reproduction is budding. Some bacteria continuously produce protrusions called buds. These buds on detachment form new individuals. One more type of asexual reproduction is the fragmentation. It occurs in colonial cyanobacteria. After reaching to a certain length, the blue bacterium breaks into many fragments, each fragment forming a new colony. Another important type of asexual reproduction is the formation of homogonia. Homogonia formation is a characteristic method of reproduction in cyanobacteria. Trichomes of the filamentous genera break up within the sheath into many small fragments of one to many uniform living cells. These short segments are called as homogonia or homogones. The homogonia may be separated by the formation of heterocysts or necretia. In addition to the normal asexual modes of reproduction, under stressful or unfavorable environmental conditions, different bacteria produce different structures that help them to undergo perennation. These structures, with the onset of the favorable conditions, germinate and form new bacteria. The most common types are: number 1, akinets. Akinets are large-sized, thick-walled, food-laden, resistant cells which are formed by cyanobacteria under unfavorable conditions. These akinets, on return of the favorable conditions, germinate to form new filaments. The second stage is the zooglea formation. When environmental conditions are adverse, some bacteria come to lie together in chains and get surrounded by a lot of mucilage. This is called as zooglea stage. This is a temporary stage for avoiding desiccation. Another survival strategy adapted by bacteria for avoiding stressful environmental conditions is the cyst formation. The parent cell secretes a highly protective thick wall called cyst wall which can resist unfavorable conditions. On return of the favorable conditions, the cyst wall dissolves and the bacteria are released. Thus, cyst formation also helps in perennation. Another important aspect of perennation strategy is the endospore formation. When the environmental conditions are adverse, some gram-positive bacteria, especially bacilli, and certain blue-green bacteria produce thick-walled resistant spores called endospores. Endospores are formed under extreme conditions of nutrient deficiency, unfavorable temperature, presence of toxic substances, etc. During endospore formation, a portion of the cytoplasm and a copy of the bacterial chromosome get dehydrated and encased by a thick wall. The rest of the cytoplasm and the bacterial cell wall deteriorate so that the endospores are released. Endospores can remain dormant for several decades and can tolerate hardest of environments. They can germinate only under favorable conditions. After discussing the asexual mode of reproduction in bacteria, we now come to another important aspect, that is the genetic recombination in bacteria. True sexual reproduction, which involves gamete formation and fertilization, is absent in bacteria, but genetic recombination takes place by conjugation, transduction, and transformation. The genetic recombination or even the conjugation is absent in cyanobacteria. Bacterial conjugation is defined as the transfer of genetic material from a donor cell to a recipient cell through a specialized intercellular connection or conjugation tube that forms between them. The donor and the recipient cells are sometimes called as male and female cells respectively. The cells that have the capacity to serve as donors during conjugation can be differentiated by the presence of specialized cell surface appendages called F. pili. The synthesis of these F. pili is controlled by several genes that are carried by a small molecule of DNA called fertility factor, or also called as F plasmid or sex factor. This F plasmid is an episome, that is, a plasmid that can exist in two different states. One, the autonomous state, in which it replicates independently of the host chromosome. And second, the integrated state, in which it is covalently inserted into the host chromosome and replicates with it like any other segment of the host chromosome. The process of conjugation can take place in several ways. One of the best examples is the conjugation between F plus male and F minus female. The bacterium E. coli shows two strains, one acting as a donor, F plus male, and another as a recipient, F minus female. The donor cell that contains fertility factor in the autonomous state, that is F plus cell, conjugates with an F minus recipient cell, and only the F factor is transferred. The fertility factor is usually accompanied by the presence of pili. They help the donor cell to get attached to the recipient cell. In the region of contact, a pilus grows in size and forms a conjugation tube. The fertility factor replicates and a copy of it gets transferred to the recipient cell, which also becomes a donor. Thus, mixing a population of F plus cells with a population of F minus cells results virtually in all the cells in the new population becoming F plus. In other words, the sex in E. coli can be called infusius. The second type of genetic recombination in bacteria is transduction. Transduction may be defined as the transfer of DNA from one bacterium to another by bacteriophages. In most of the cases, only a small segment of the host DNA is transferred. Transduction happens through either the lytic cycle or the lysogenic cycle. Based on their interactions with the bacterial cell, the bacteriophages can be of two types. Number one, the virulent phages, which enter the lytic cycle, during which they reproduce and lyse their host cells. And number two, the template phages, which enter the lysogenic cycle, during which the phage chromosome is integrated into the bacterial chromosome, where it can remain dormant for thousands of generations and replicate like any other segment of the host chromosome. If the lysogen is induced, the phage chromosome is excised from the host chromosome and initiates the lytic cycle, which culminates in the lysis of the host cell and the release of the phage particles. Transduction in bacteria can be of two types. First, generalized transduction, which can transfer any part of the host DNA, and second, specialized transduction, which is restricted to the transfer of specific DNA segments only. Generalized transduction is mediated by virulent phages, and the generalized transducing particles are produced during the lytic cycles of these phages. Specialized transduction is mediated by template phages, whose chromosomes are able to integrate at one or a fifth specific sites on the host chromosome. In its integrated state, the phage chromosome is known as a prophage. So, these are the examples of genetic elements called episomes. The third type of genetic recombination in bacteria is transformation. The uptake and incorporation of DNA by bacteria is called as transformation, and the normal ability of the bacteria to take up exogenous DNA from the environment is called as competence. Therefore, transformation may be defined as gene transfer by a soluble or naked DNA which has been extracted or otherwise liberated from a donor bacterium to a recipient bacterium. This is the longest known and historically the most important kind of gene transfer in bacteria. After discussing the three main types of genetic recombination in bacteria, we can conclude that the conjugation in bacteria occurs by direct cell-to-cell contact, but transduction and transformation do not involve any such contact. The transfer of genetic material in bacteria is thus a one-way transfer rather than a reciprocal exchange of genetic material. This phenomenon has been called as parasexuality or genetic recombination. With this, we come to the conclusion of the present topic, that was bacterial reproduction. We hope it helps your understanding of the bacterial reproduction. Thank you. Welcome friends to a new session on Informatics and Introduction to Bioinformatics. In this session, we are going to study about computer networks and internet. Overview of Information Technology, Part 3, Computer Networks and Internet. Computer networks. A computer network is a group of computer systems and other computing hardware devices that are linked together through communication channels to facilitate communication and resource sharing among a wide range of users. Networks are commonly categorized based on their characteristics. There are many types of computer networks, including LAN, WAN, CAN, MAN, and HAN. Local area networks or LANs. A local area network is a network that is confined to a relatively small area. It is generally limited to a geographic area such as a writing lab, school, or building. A LAN is useful for sharing resources like files, printers, games, or other applications. A LAN in turn often connects to other LANs and to the internet or other WAN or WANs. Most local area networks are built with relatively inexpensive hardware such as Ethernet cables, network adapters, and hubs. Wireless LAN and other more advanced LAN hardware options also exist. Specialized operating system software may be used to configure a local area network. For example, most flavors of Microsoft Windows provide a software package called Internet Connection Sharing or ICS that supports controlled access to LAN resources. The most common type of local area network is an Ethernet LAN. The smallest home LAN can have exactly 2 computers. A large LAN can accommodate many thousands of computers. Wide area networks or WANs. A WAN is a geographically dispersed collection of LANs. As its name suggests, it is a computer network that covers a far wider area than a LAN or a local area network. A network device called a router connects LANs to a WAN. In IP networking, the router maintains both a LAN address and a WAN address. A WAN differs from a LAN in several important ways. Most WANs, like the internet, are not owned by any one organization, but rather exist under collective or distributed ownership and management. When networks connect to form a bigger network, the resulting network is called an internetwork, which is generically abbreviated to an internet. Now, when all WANs in the world connect, forming a global internet, we call it the internet, which everyone knows. That's why the internet is always written with a capital I. It is the biggest WAN we have. WANs generally utilize different and much more expensive networking equipment than do LANs. Campus area networks or CANs. The computers are within a limited geographic area, such as a campus or military base. Metropolitan area networks or MANs. A data network designed for a town or a city is called as a MAN. Home area networks or HANs. HANs are networks which contain within a user's home that connects a person's digital devices.
In addition to these types, the following characteristics are also used to characterize different types of networks: star network, bus network, ring network. Bus topology. Do not be confused with the system bus of a computer whenever you refer the term bus network. Bus networks use a common backbone to connect all devices. A device wanting to communicate with another device on the network sends a broadcast message onto the wire that all other devices see, but only the intended recipient actually accepts and processes the message, as you can see in figure 1, which is the bus topology. Ring topology. In a ring network, every device has exactly 2 neighbors for communication processes, as you can see in figure 2. All messages travel through a ring in the same direction, either clockwise or counterclockwise. A failure in any cable or device breaks the loop and can take down the entire network. To implement a ring network, one typically uses FTDI, SONET, or token ring technology. Ring topologies are found in some office buildings or school campuses. Star topology. Many home networks use the star topology. A star network features a central connection point called a hub node. That may be a network hub, switch, or router. Devices typically connect to the hub with unshielded twisted pair or UTP Ethernet. Compared to the bus topology, a star network generally requires more cable, but a failure in any star network cable will only take down one's computer network access and not the entire LAN. Internet. The internet is a global network connecting millions of computers. More than 100 countries are linked into exchanges of data, news, and opinions. The term internet stands for Inter-Network Systems. It is a global network of networks. It is an exceptional means of communication. No one actually owns the internet, and no single person or organization controls the internet in its entirety. The internet is more of a concept than an actual tangible entity, and it relies on a physical infrastructure that connects networks to other networks. The internet is at once a worldwide broadcasting capability, a mechanism for information dissemination, and a medium for collaboration and interaction between individuals and their computers without regard for geographic location. The internet represents one of the most successful examples of the benefits of sustained investment and commitment to research and development of information infrastructure. Beginning with the early research in packet switching, the government, industry, and academia have been partners in evolving and deploying this exciting new technology. Some important applications of the internet are email. Email is the most widely used internet service, and it has abolished the notion of distance. To send a message through email, one has to type a message, and it would travel instantly over the network to whomever one wishes. FTP, or File Transfer Protocol. A client-server protocol allows a user on one computer system to transfer files to and from another computer system. World Wide Web, or WWW. There is an incredible amount of information on the internet, and it is growing exponentially. World Wide Web, a product of the continuous search for innovative ways of searching information, is a mechanism that links together information stored on many computers throughout the world. One of the important characteristics of the World Wide Web documents is the hypertext structure created by Hypertext Markup Language, or HTML, a simple data format. The simplicity of the HTML used for interactive documents allows a user to contribute to the expanding database of documents. The possibilities for hypertext in the World Wide Web environment are endless. HTTP and HTML. Short for Hypertext Transfer Protocol, the underlying protocol used by the World Wide Web. HTTP defines how messages are formatted and transmitted and what actions web servers and browsers should take in response to various commands. For example, when you enter a URL in your browser, this actually sends an HTTP command to the web server, directing it to fetch and transmit the requested web page. The other main standard that controls how the World Wide Web works is HTML, which covers how web pages are formatted and displayed. Short for Hypertext Markup Language, the authoring language used to create documents on the World Wide Web. HTML defines the structure and layout of a web document by using a variety of tags and attributes. The correct structure for an HTML document starts with HTML, head, body, which includes the body of the document, and ends with /body and /HTML. All the information you'd like to include in your web page fits in between the body and /body tags. There are hundreds of other tags used to format and lay out the information in a web page. Tags are also used to specify hypertext links. These allow web developers to direct users to other web pages with only a click of the mouse on either an image or word. Internet functions. The internet provides for the following 2 functions which support communications. Without the communication support mentioned below, the internet could not function. These 2 functions are provided by internet service providers listed below under the Internet Organization's header. Physical lines that data is sent across. Routing of data. There are special machines on the internet called routers that determine where data needs to go to get from the sender of the data to the receiver of the data. Search engines. Search engines are programs that search documents for specified keywords and return a list of the documents where the keywords were found. A search engine is really a general class of programs. However, the term is often used to specifically describe systems like Google, Bing, and Yahoo, etc. Search that enable users to search for documents on the World Wide Web. Google. Google is the undisputed king of Spartan searching. While it doesn't offer all shopping center features of Yahoo, Google is fast, relevant, and the largest single catalog of web pages available today. Make sure you try the Google Images, Maps, and News features, the outstanding services for locating photos, geographic directions, and news headlines. Yahoo. Yahoo is several things. It is a search engine, a news aggregator, a shopping center, an email box, a travel directory, a horoscope and game center, and more. This web portal, breadth of choice, makes this a very useful and helpful site for internet beginners. Searching the web should also be about discovery and exploration, and Yahoo delivers that in wholesale quantities. Web browsers. Web browser is a software application for retrieving, presenting, and traversing information resources on the World Wide Web. Commonly used web browsers are the following, such as Internet Explorer. Internet Explorer is a web browser that made its debut in 1995 as Microsoft's response to Netscape, one of the first graphical-based web browsers. Initially called Microsoft Internet Explorer, or MSRE, Internet Explorer has long held the title of most popular browsers in use, despite strong competition from the likes of Mozilla Firefox, Apple Safari, Opera, and Google Chrome. Mozilla Firefox. Mozilla Firefox is a good free alternative browser to Internet Explorer. Mozilla Firefox is faster than Internet Explorer. Additionally, many corporate IT departments find that Mozilla Firefox is less vulnerable to viruses and malicious code. Internet Explorer has been fraught with security holes for years, and even with the release of Internet Explorer 7, Firefox remains the browser of choice. This added protection is not merely the result of being a smaller target for potential attackers. Google Chrome. Chrome is probably the most flexible and fully featured browser out there. Google has been an innovator when it comes to web browsing from the start. They revolutionized search by combining the address bar with a search bar and by making tabbed browsing so smooth and easy that switching to tabbed browsing was irresistible. Chrome definitely still gives the best tabbed browsing experience as it provides a layout that allows for far more space than either Firefox or Internet Explorer. Chrome gives you all the standard internet settings that you can tweak at will and has also introduced Sync. With Sync, you log into Chrome using a Google network on one computer, and when you log into Chrome with the same account on a different computer, all your settings, bookmarks, and even the tabs you had opened will transfer to the new browser. You have many options on what to and what not to sync, so you can still keep some things customized for every computer if you want to. Sync is an amazing feature if you use multiple computers, as you'll never have to import or export bookmarks or other information again. Chrome also has an application store full of all kinds of applications, add-ons, music, books, etc., and even allows you to see your applications on the startup or new tab page if you choose to. It also offers to show thumbnail previews of your most visited sites as a startup or new tab page if you prefer. On top of these great features, Chrome also carries the standards like bookmarks, RSS feeds, password manager, download manager, find, private browsing, autofill, automatic updates, zoom, spell check, and more. For most people, this will probably be the most fully featured browser, but if you are a developer, Mozilla's Firefox is more specialized in those tools. Apple's Safari. Safari is Apple's stylish, easy-to-use web browser for its Mac operating system. Safari for Windows lets PC users try Safari for themselves. Safari is a great way for Windows users to take a bite of the apple, since as a web browser, it can only be so different from the big three: Internet Explorer, Firefox, and Chrome. Safari's page layout shows how much web browser functionality dictates from these days. Safari for Windows is plain but clean and intuitive, with many similarities to other popular browsers as well as some differences. For instance, the address bar searches the history rather than using your default search engine. Safari has a separate search field instead. The settings icon opens an extensive menu that includes private browsing, pop-up locking, extensions, and customization buttons. One feature we really like is the page icon that displays a menu just for the current page. The bookmarks bar hold icons to show the reading list, top sites, and all bookmarks. Opera. The perk to Opera is that the updates are fast and do not require that you restart your computer. You will have to exit the browser and reopen it, but that takes a lot less time than restarting your computer. Updates pop up when available. Some of them can really improve the performance and speed, while others can't be skipped over until you know there is something that needs updating. You can highlight text and paste it to the note feature. To access, just click inside a search box or search bar, or you can even use the find option from the edit tab and then right click. You will see insert note, and when you hover over it, you will see the list of items you have stored there. To edit it, go to tools and then notes and delete or edit any one of the things you have there. Internet address. An internet address uniquely identifies a node on the internet. Internet address may also refer to the name or IP of a website or URL. The term internet address can also represent someone's email address. URL, or Uniform Resource Locator, is the global address of documents and other resources on the World Wide Web. The first part of the URL is called a protocol identifier, and it indicates what protocol to use, and the second part is called a resource name, and it specifies the IP address or the domain name where the resource is located. The protocol identifier and the resource name are separated by a colon and 2 forward slashes. A URL is one type of Uniform Resource Identifier, the generic term for all types of names and addresses that refer to objects on the World Wide Web. IP address. IP address is short for Internet Protocol Address. An IP address is an identifier for a computer or device on a TC/IP network. Networks using the TCP protocol route messages based on the IP address of the destination. The format of an IP address. The format of an IP address is a 32-bit numeric address returned as 4 numbers separated by periods. Each number can be 0 to 255. For example, 1.160.10.240 could be an IP address. Within an isolated network, you can assign IP addresses at random as long as each one is unique. However, connecting a private network to the internet requires registered IP addresses, also called as internet addresses, to avoid duplicates. An IP address can be static or dynamic. A static IP address will never change, and it is a permanent internet address. A dynamic IP address is a temporary address that is assigned each time a computer or device accesses the internet. Let us now summarize what we have studied in this session. Internet is a collection of organizations that provide equipment that support the internet functions and services. The internet connects many corporate and organizational private networks together, thus enabling all these organizations to easily communicate. In computer networking, topology refers to the layout of connected devices. For example, the computers on a home LAN may be arranged in a circle in a family room, but it would be highly unlikely to find a ring topology there. Network topologies are categorized into the following basic types: bus, ring, star, etc. LAN uses a star topology in which all nodes are connected to a central computer. Bus topology is a network in which all nodes are connected to a single wire that has 2 endpoints. In ring topology, all of the nodes are connected in a closed loop. Messages travel around the ring, with each node reading those messages addressed to it. People use an internet browser to access web pages that are available across the internet. Internet browsers include Microsoft Internet Explorer, Netscape Navigator, Mozilla, and others. Web pages are created in a markup form of text file called HTML, Hypertext Markup Language. The markup within the text indicates document structure, showing where paragraphs begin and end, what items are in a list, headers, tables, and other document structure. Hence, information technology helps people to keep in contact with family and friends via email, manage their finances with spreadsheets and online banking, track investments through an online broker, pursue hobbies like genealogy or gardening with specialized software packages, help their children with homework and school projects using word processing and graphing tools, find medical information, become informed about political candidates and communicate with their political representatives, and track environmental issues or monitor public policy issues over the World Wide Web. Here are some assignments for you to work out. 1. Give a brief discussion on the influence of computer and internet in day-to-day life. 2. Explain about web browsers. 3. Give a note on supercomputer. 4. How do we create web pages by HTML language? The following are some books and websites for your reference. B. Rajaraman, Fundamentals of Computers, 2005, 4th edition, Prentice Hall India Private Limited, New Delhi. Websites are www.internetsociety.org/internet, www.windows.microsoft.com, www.compnetworking.about.com. Thank you for watching this session. Let us meet in the next section. Until then, bye.
The ion exchange process requires a plant having cation or anion exchange resins. The cation exchange resin process is the exchange of cations of substances dissolved in water with the cations of the solid insoluble substances dissolved in water with the cations of the solid insoluble substances called catenoid. Catenoid is also called the cation exchanger. The cations of the catenoid released or exchanged are called exchange cations. Cations exchangers are also termed as cation exchange resins. As an example, one of the most successful cation exchange resin, namely cross-linked polystyrene, is described here. With the aid of a cross-linking agent, namely divinyl benzene, the polymerization of a suspension of styrene in water is carried out to produce this resin from convenience of packing in the softening plant. This polymer is produced in the form of spherical granules. To produce a product which reacts with bivalent metal ions such as calcium or magnesium, the resin is further treated with sulfuric acid, which introduces sulfonic groups into the polystyrene as shown in the following formula. Coming to the sequencing method. Sequencing agents are those compounds which inactivate the metal ions like calcium and magnesium from having a determinal effect by enclosing them in a ring structure. There are two types of sequencing agents, namely organic and inorganic. Stewart Bisson, a scientist, found that amino polycarboxylic acids are excellent complexing agents. The most important of these is ethylene diamine tetraacetic acid, that is EDTA. The sodium salt of EDTA is commonly used, the formula of which is given below. Addition of EDTA to water with hardness has a reducing effect on pH as stated in the experiment. For a disodium salt of EDTA, this observation can be explained by the following reaction. If the disodium salt is represented by NS2H2Y, the reaction with the cation M++ can be written as follows. The metal ions are made inactive by the sequencing agents due to the formation of chelate rings. Some ligands like EDTA attach to the metal atom with more than one donor atom so as to form a heterocyclic ring. This type of ring is called a chelate ring, and the process of forming this ring is called chelation.
Greetings friends, and welcome to the final part of the series of lectures on the topic ionic equilibrium. In today's lecture we shall discuss first acid-base titrations, second acid-base titration curves, third acid-base indicators, then mechanism of action of indicators, and finally the role of indicators in different acid-base titrations. Now to begin with, let us see what actually titration means. It's a volumetric analysis technique in which a solution of known concentration called the titrant is slowly added to another solution of unknown concentration until the reaction reaches neutralization, which is often indicated by a color change. Acid-base neutralizations through titration allows for quantitative analysis of the concentration of an unknown acid or base solution. Now pH titration curves. Titration curves are graphic representations of acid-base titrations which generally contain the volume of the titrant as the independent variable and the pH of the solution as the dependent variable, because it changes depending on the composition of the two solutions. Let's now see how pH changes during different acid-base titrations and how acid-base titration curves look. When we carry out a simple acid-base titration, we use an indicator to tell when we have the acid and alkali mixed in exactly the right proportions to neutralize each other. When the indicator changes color, this is often described as the endpoint of the titration. In an ideal world, the color change would happen when we mix the two solutions together in exactly equal proportions. That particular point is known as the equivalence point. For example, if we were titrating sodium hydroxide solution with hydrochloric acid, both with a concentration of 1 mole per decimeter cube, 25 centimeter cube of sodium hydroxide would need exactly the same volume of the acid because they react 1:1 according to the equation. Sodium hydroxide aqueous plus hydrochloric acid HCl aqueous gives NaCl aqueous plus H2O in its liquid form. In this particular instance, this would also be the neutral point of the titration because sodium chloride solution has a pH of 7. But that isn't necessarily true of all the salts that might get formed. For example, if we titrate ammonia solution with hydrochloric acid, we would get ammonium chloride formed. The ammonium ion is slightly acidic, and so pure ammonium chloride solution has an acidic pH. That's a pH lesser than 7. That means at the equivalence point where we had mixed the solution in the correct proportions according to the equation, the solution wouldn't actually be neutral. To use the term neutral point in this context would be misleading. Similarly, if we titrate sodium hydroxide solution with ethanoic acid, at the equivalence point, the pure sodium ethanoate formed has a slightly alkaline pH because the ethanoate ion is slightly basic. The term equivalence point means that the solutions have been mixed in exactly the right proportions according to the equation. The term endpoint represents the stage where the indicator changes color. As we will learn later, endpoint isn't necessarily exactly the same as the equivalence point. Now, there are various types of pH curves. They range from simple to very complex. Let's first discuss what simple pH curves mean. All the titration curves that will be discussed ahead are based on both acid and alkali having a concentration of 1 mole per decimeter cube. In each case, we start with 25 centimeter cube of one of the solution in the flask and the other one in a burette. Titration curves for a strong acid and strong base. To discuss this, we'll take hydrochloric acid and sodium hydroxide as typical of a strong acid and a strong base titration. Numerically, we can have sodium hydroxide NaOH aqueous plus hydrochloric acid HCl aqueous gives NaCl aqueous plus water in its liquid form. Now there are two cases. Either we can run acid into the alkali or we can run alkali into the acid. The first one is running acid into the alkali. As depicted from the graph, we can see that the pH only falls a very small amount until quite near the equivalence point. Then there's a really steep plunge. If we calculate the values, the pH falls all the way from 11.3 when we have added 24.9 centimeter cube to 2.7 when we have added 25.1 centimeter cube. The second case would be running alkali into the acid. This is very similar to the previous curve except that the pH starts off low and increases as we add more sodium hydroxide solution. Again, the pH doesn't change very much until we get close to the equivalence point. Then it surges upwards very steeply. The second case would be titration curves for strong acid and weak base. This time, let's take hydrochloric acid as the strong acid and ammonia solution as the weak base. Numerically, we can show NH3 aqueous, that is ammonia, plus hydrochloric acid HCl aqueous gives NH4Cl ammonium chloride in its aqueous form. At the very beginning of the curve, the pH starts by falling quite quickly as the acid is added, but the curve very soon gets less steep. This is because a buffer solution is being set up composed of the excess ammonia and the ammonium chloride being formed. We can notice that the equivalence point is now somewhat acidic, a bit less than pH 5, because pure ammonium chloride isn't neutral. However, the equivalence point still falls on the steepest bit of the curve. That will turn out to be important in choosing a suitable indicator for the titration. The third is titration curves for weak acid and strong base. As an example, let's take ethanoic acid and sodium hydroxide as typical of a weak acid and a strong base. Numerically, CH3COOH aqueous, that is ethanoic acid, plus sodium hydroxide NaOH aqueous gives CH3COONA, that is sodium ethanoate aqueous, plus H2O, that is water. As can be seen from the graph, there is steep fall in pH till 25 centimeter cube of base is added. Past the equivalence point, we have a buffer solution containing sodium ethanoate and ethanoic acid. This resists any large fall in pH. Then there's a case of titration curve for weak acid and weak base. The common example of this would be ethanoic acid and ammonia. Numerically, we can write CH3COOH aqueous plus NH3 aqueous gives CH3CONH4, that is ammonium ethanoate aqueous. It so happens that these two are both about equally weak. In this case, the equivalence point is approximately pH 7, that is at a neutral pH. This is really just a combination of graphs we have already seen. Up to the equivalence point, it is similar to the ammonia hydrochloric acid case. After that equivalence point, it is like the end of the ethanoic acid sodium hydroxide curve. As can easily be seen, this titration doesn't have a steep pH fall. Lack of a steep bit means that it is difficult to do a titration of a weak acid against a weak base. Now, the next important point is what acid-base indicators mean and how are they helpful. An indicator is a large organic molecule that works somewhat like a color dye. Whereas most dyes do not change color with the amount of acid or base present, there are many molecules known as acid-base indicators which do respond to a change in the hydrogen ion concentration. Most of the indicators are themselves weak acids. A variety of indicators change color at various pH levels. A properly selected acid-base indicator can be used to visually indicate the approximate pH of a sample. An indicator is usually a weak organic acid or base dye that changes color at definite pH values. The weak acid form, that is H indicator, HIN, will have one color, and the weak acid negative ion, IN negative, indicator negative, will have a different color. The weak acid equilibrium can be shown as HIN, that is H indicator gives H positive plus indicator negative. For example, phenolphthalein at a pH of 8.2 is colorless, while as it is red at a pH of 10. Similarly, bromophenol blue is yellow at a pH of 3 and it is blue at a pH of 4.6. Methyl orange is red at a pH of 3.1 and yellow at pH above 4.4. Let's now discuss the molecular basis for the indicator color change. Color changes in molecules can be caused by changes in electron confinement. More confinement makes the light absorb more blue and less dispersal makes it more red. The molecular basis is the extent of conjugation and the HOMO, that is highest occupied molecular orbital, dash LUMO, that is lowest unoccupied molecular orbital energy gap. Let's take the example of phenolphthalein and understand how it works. There are 3 benzene rings in phenolphthalein. Every atom involved in a double bond has a p orbital which can overlap side to side with similar atoms next to it. The overlap creates a pi bond which allows the electrons in the p orbital to be found on either bonded atom. These electrons can spread like a cloud or any region of the molecule that is flat and has alternating double and single bonds as it is completely conjugated. Each of the benzene rings is such a system. The carbon atoms at the center, adjacent to the yellow circled red oxygen atom, doesn't have a p orbital available for pi bonding and it confines the pi electrons to the rings. The molecule absorbs in the ultraviolet and this form of phenolphthalein is thus colorless. However, in basic solution, the molecule loses one hydrogen ion. Almost instantly, the 5-sided ring in the center opens and the electronic structure around the central carbon changes to a double bond, which now does contain pi electrons. The pi electrons are no longer confined separately to 3 benzene rings, but because of the change in geometry around the yellow circled atom, the whole molecule is now flat and electrons are free to move around the entire molecule. The result of all of these changes is that the molecule absorbs invisible region and the change in color is to pink. Many other indicators behave on the molecular level in a similar fashion. The details may be different, but the result is a change in electronic structure along with the removal of a hydrogen ion from the molecule. Plant pigments in flowers and leaves also behave in this fashion and are thus colored in nature. There are various types of indicators that are used in day-to-day practice. Among them, few are discussed as methyl orange. Methyl orange is a pH indicator frequently used in titrations because of its clear and distinct color changes. Because it changes color at the pH of a mid-strength acid, it is usually used in titrations for acids. Unlike a universal indicator, methyl orange does not have a full spectrum of color change, but has a sharper endpoint. In the methyl orange case, the half-phase stage where the mixture of red and yellow produces an orange color happens at pH of 3.7, nowhere near neutral. Thus, this is an acidic indicator because it operates in a pH which is much below 7. Another very important indicator that's commonly used is phenolphthalein. Phenolphthalein is a weak acid, and in its case, the weak acid is colorless and its ion is bright pink. Adding hydroxide ions removes the hydrogen ions from the equilibrium, which tips to the right to replace them, turning the indicator pink. The half-phase stage happens at pH 9.3. Since a mixture of pink and colorless is simply a paler pink, this is difficult to detect with an accuracy. Now, the next very important point is the pH range of indicators. Indicators do not change color sharply at one particular pH, given by their pK indicator. Instead, they change over a narrow range of pH. Assume that the equilibrium is firmly to one side, but now we add something to start to shift it. As the equilibrium shifts, we'll start to get more and more of the second color formed, and at some point, the eye will start to detect it. For example, suppose we have methyl orange in an alkaline solution, so that the dominant color is yellow. Now, if we start to add acid so that the equilibrium begins to shift, at some point, there will be enough of the red form of the methyl orange present that the solution will begin to take an orange tint. As we go on adding more and more acid, the red will eventually become so dominant that we can no longer see any yellow. There's a gradual smooth change from one color to the other, taking place over a range of pH. As a rough rule of thumb, the visible change takes place at about pH 1 unit to either side of the pK indicator value. The exact values for the three indicators we have looked at are litmus, having a pK indicator value of 6.5 and works in the pH range 5 to 8. Methyl orange has a pK indicator value of 3.7 and works in the pH range of 3.1 to 4.4. Similarly, phenolphthalein has a pK indicator value of 9.3 and it works in the pH range of 8.3 to 10. The litmus color change happens over an unusually wide range, but it is useful for detecting acids and alkalis in the lab because it changes color around pH 7. Choosing right indicators for titrations. We should remember that the equivalence point of a titration is where we have mixed the two substances in exactly equal proportions. We obviously need to choose an indicator which changes color as close as possible to that equivalence point. That varies from titration to titration depending on the nature of the acid and the base that are being titrated against one another. That's all we have for you in today's lecture. Hope you have understood it well. Thank you and goodbye.
The name of the rose flower comes from the root Greek word rhode, meaning red. The famous island of Rhodes received its name from the huge quantities of rose that grew wild on its rocky shores. Fossil records indicate that the rose is an ancient plant. Theophrastus, the father of botany himself, had gone on record stating that roses yield better flowers if they are occasionally pruned. Emperor Nero is known to have spent 17,000 pounds on a single occasion on roses alone. Roses grow best in loamy and neutral soil. Decaying plant leaves, tea leaves left after preparing tea, hoof and horn meal, bone meal, and sulfates of potash serve as a good manure for it. Care has to be taken to avoid waterlogging. Due to Theophrastus, pruning can be done to get flowers of larger size. In India, November and December are the right months for pruning. The fair and beautiful rose is a global phenomenon. Europe has its Rosa gallica, India and China have Rosa moschata and Rosa indica, and Rosa vishuraina can be seen in Japan. The rose plant is an annual or perennial shrub. Some varieties of it are also scramblers. The rose plant has an adventitious root system. Its stem is herbaceous or woody. It is reddish or green in color and is provided with prickles or thorns for protection from grazing animals. Its leaves are compound and imperipinnate. They are alternately arranged on the branches. The leaves are stipulate and of adnate type, containing 3 to 5 pinnae. The shape of the lamina is ovate and the leaf margin serrate. The apex of lamina is acute. Its venation is of unicostate reticulate type. The inflorescence of rose plant is solitary and axillary. Usually the flowers are produced singly, but in some species, especially in climbers, they are produced in clusters. Flowers are bracteate, actinomorphic, complete, bisexual, spirocyclic, pentamerous, and perigynous. The calyx consists of 5 lobed sepals fused at the base with valvate estivation. One of the sepals is generally leaf-like. The corolla is polypetalous, that is, made up of numerous petals arranged in cycles of 5 petals each. The color of petals may be red, yellow, white, black, orange, or even green. In garden varieties, the number of petals is indefinite because the outer stamens are transformed into petals. The androecium has numerous stamens. The filament of stamens is thin, long, petaloid, and spirally arranged round the periphery of the hypanthium. The anthers are small, diathecous, and dorsifixed with the filament. Outer stamens get transformed into petals. This phenomenon is called doubling or corysis. The gynoecium of rose is multicarpellary and apocarpous. The carpels are enclosed within the cup of hypanthium. The ovary is half inferior and unilocular with single ovule in each carpel. Placentation of the ovule is basal. Styles are long and curved. Stigma is globular type, and ovary and styles are hairy. The fruit of rose is an aggregate of small achenes. The cup enclosing the achenes becomes yellow or red colored after maturity and is then known as hip. In garden varieties, usually fruit formation and seed setting is suppressed. The rose is usually grown from cuttings. In nurseries, some plant hormones are applied to the cuttings before planting them to facilitate the growth of roots. Some of such plant hormones are rutone or indole butyric acid and hortomone or naphthalene acetic acid. The floral formula of rose is bracteate, actinomorphic, bisexual, calyx of 5 sepals, gamosepalous, corolla with several whorls of 5 petals each, androecium of indefinite number of stamens, and gynoecium of indefinite number of free carpels with half inferior ovary. The floral diagram of rose is: since the flowers of rose are available in a wide variety of colors, grafting can produce incredible results.
Dear students, welcome to all of you. Today we are here to discuss morphology, anatomy and reproduction of genus Pteris of pteridophytes. The name Pteris is derived from pteron, a feather, due to the feathery appearance of the fronds. The English name fern is a contraction of the Anglo-Saxon piperon, that is a feather. In some parts of England, it is called King Charles in the oak tree. In Scotland, it is said to be an impression of the devil's foot, and yet witches were reputed to detest this fern for the reason that it bears on its cut stem the Greek letter X, which is the initial of the Christos. In Ireland, it is called the fern of God, because if the stem is cut into 3 sections, on the first of these will be seen the letter G, on the second O, and on the third D. So far the systematic position of genus Pteris is concerned, it belongs to kingdom Plantae, phylum Pteridophyta, class Phelicopsida, order Polypodiales, family Pteridaceae. The genus Pteris is a large and diverse genus of about 280 terrestrial and epiphytic species of ferns of predominantly tropical and subtropical regions. The species grow in moist, shady forests and on hillsides. Many species are found on the roadsides and valleys of western and northwestern Himalaya. The common species in India are Pteris vittata, Pteris critica, Pteris biaurita, Pteris quadriaurita, Pteris stenophylla, and Pteris welchiana. The Pteris vittata is a low-level fern and brings out new leaves throughout the year. It is very common along mountain walls and grows up to 1,200 meter altitude. Now the morphology of the sporophyte. The dominant stage in the life cycle of Pteris constituting the main plant body is the sporophyte. It is differentiated into roots, stem and leaves. The primary root formed from embryo is short-lived and is soon replaced by the adventitious roots. These roots are slender, black, wiry and arise from ventral side of rhizome or from all over the surface. The system is perennial, rhizomatous, underground, branched, and covered by brown scales. Some species have persistent leaf bases on the rhizome. The leaves are macrophyllous, unipinnate, and arise acropitally on the rhizome. Bipinnate leaves are seen in Pteris biaurita. Decompound and digitate leaves are also present. Fully developed leaves are known as fronds. The petiole base is covered with brown scales and sometimes with ramenta. The rachis has several sessile, lanceolate, coriaceous leaflets arranged in pairs except the terminal one. The leaflet is broader at the base and gradually tapers towards the apex. The middle leaflets are larger and the other leaflets show gradual decrease in size towards the basal and apical regions of the rachis. The leaflet is topped, has a midrib from which arise the lateral veins with dichotomous branching. The venation is open dichotomous. The younger leaves show circinate vernation. Growth rate is very slow. Now the anatomy of sporophyte. First, the anatomy of rhizome. In transverse section, the rhizome is oval in outline and differentiated into epidermis, cortex, and stele. The epidermis is single-layered with quadrangular cells. The epidermis is covered by thick cuticle. The cortex is multi-layered and differentiated into 4 to 5 layered sclerenchymatous hypodermis and inner multi-layered broad parenchymatous region. The parenchymatous region has root traces and leaf traces. The stellar structure differs from species to species. In Pteris vittata, it is dictostele with a ring of vascular strands that is meristeles. Meristeles are embedded in the parenchymatous ground tissue. Each meristele is elliptical with single-layered endodermis having Casparian strips in its radial walls. 1 to 2 layered thin-walled pericycle is present below the epidermis and surrounding the phloem. Phloem has only sieve cells and phloem parenchyma. It completely surrounds the xylem. Xylem is present at the center of meristele. It consists of tracheides and xylem parenchyma. Now the anatomy of rachis. In transverse section, the outline of rachis or petiole is semicircular. It is differentiated into epidermis, ground tissue, and vascular bundle. The epidermis is single-layered with narrow quadrangular cells covered by thick cuticle. Some epidermal cells give rise to uniseriate bicellular hairs called as ramenta. The ground tissue has multi-layered sclerenchymatous hypodermis, followed by parenchymatous tissue in which the vascular bundle is embedded. The vascular bundle is V-shaped or U-shaped and embedded in the parenchymatous ground tissue. Pericycle is 1 or 2 layered and parenchymatous. Xylem is at the center with meso-arch condition surrounded by phloem. Now the anatomy of leaflet. Leaflet has epidermis, mesophyll, and vascular bundle. The epidermis is single-layered, present on both the upper and lower surfaces. It has stomata only on the lower epidermis. The mesophyll is either homogeneous or differentiated into upper palisade and lower spongy with broader intercellular spaces. Hypodermal region of midrib has sclerenchymatous strips on both abaxial and adaxial sides. Midrib has single concentric amphicribal vascular bundle surrounded by single-layered pericycle and endodermis. The vascular strands are embedded in the mesophyll. Now the root anatomy. Root is circular in outline and distinguished into epidermis, cortex, and stele. The epidermis is single-layered with thin-walled cells. A few cells form the root hairs. The cortex is multi-layered and differentiated into parenchymatous outer cortex, sclerenchymatous inner cortex, and a single-layered endodermis with Casparian thickenings. The stele has single-layered thin-walled pericycle, central plate-like exarch and diarch xylem surrounded on either side by phloem. Now the reproduction of genus Pteris. The Pteris sporophyte reproduces vegetatively and asexually. First, the vegetative reproduction. It takes place by progressive death and decay of older portions of the rhizome. When the decay reaches the point of branching, the main axis and branch get separated and grow as individual plants. Asexual reproduction. The asexual reproduction takes place by spore formation. Genus Pteris is homosporous and produces only one type of spores. Now the sorus structure. The spores are formed in sporangia arranged in sore on a sporophyll. The fertile frond with sporangia is called as sporophyll. Sporangia are formed in groups known as sore. A sorus is developed from a pad of tissue known as receptacle or placenta on the lower surface nearer to the margin of leaflet of sporophyll. Every leaflet has 2 sore, one on each side. Since the sorus is extended as a narrow line along the margin except at some length at the apical and basal regions, it is called as linear sorus. It is called as mixed sorus because both young and old sporangia are intermingled. As the sorus has several sporangia, it is actually a cynosorus. Besides sporangia, there are multicellular uniseriate sterile structures known as paraphyses, developing from placenta. The sorus is protected by a reflex margin of the leaflet known as the phallus indusium. Structure of sporangium. The sporangium shows leptosporangiate development because it is developed from a single initial. It has a multicellular, long cylinder stalk called pedicel or seta and a globose or oval body known as capsule or spore sac. The spore sac has a single layered jacket. Some cells of the jacket are modified to form an annulus and a stomium. Annulus is a ring-like structure with vertically elongated cells. It begins from the stalk on one side, encloses the top, and extends up to halfway on the other side, while it joins with the epistomium of stomium. The annulus cells have thin outer tangential and lateral walls and thickened inner tangential and radial walls. It helps in the dehiscence and dispersal of spores. The stomium is present in between the end of annulus and stalk that forms the remaining portion of the ring. The stomium cells are long, flat and thin-walled and permit easy cleavage of the sporangium and dehiscence. The middle two cells of the stomium are narrow, radially elongated and called as lip cells. 2 or 3 cells present above the lip cells form the epistomium, and the 2 or 3 cells below the lip cells form the hypostomium. The other cells of jacket are thin-walled and polygonal or hexagonal. Anterior to the jacket, a 1 or 2 layered nutritive tissue, the tapetum, is present. It encircles the sporogenous tissue. The sporogenous tissue usually forms 12 spore mother cells that divide meiotically and form 48 haploid, morphologically similar spores, that is homospores. The young sporangium is green while the mature sporangium is dark brown. Now the sporangial dehiscence. At maturity, the capsule is dry. In dry conditions, the annulus contracts and the sporangial wall is broken transversely at stomium between the lip cells. The stomium bends backwards, carrying the upper half of the broken capsule containing the spores that are exposed for wind dispersal. When the annulus absorbs moisture, it flips forward, hurling the spores with some force and snaps back to its original position. This mechanism of spore dispersal is known as sitting or catapult mechanism. The spores are carried away by wind and remain viable for a longer period. The spores are reddish brown and triangular and have clear triradiate mark known as trilete on their surface. Spore wall has outer thick sculptured axine that is exospore and inner thin smooth intine or endospore. It is uninucleate and unicellular. Now the sexual reproduction of genus Pteris. Each spore germinates and forms the gametophytic phase called the prothallus, which reproduces sexually. The prothallus of Pteris is quadrate, dorsiventrally flattened, anterior-posterior with apical notch at the anterior side. It is parenchymatous and multicellular with thickened center that gradually thins down towards the margin. Below the notch, it has a few meristematic cells. The cells are polygonal with protoplast showing primordial utrical condition with disc-shaped chloroplasts and haploid nucleus in every cell. It has unicellular rhizoids at the posterior side on the ventral surface, among which the antheridia are developed. Below the notch, the female sex organs, that is archegonia, are present. The prothallus is usually monoecious, but sometimes also dioecious. The sex organs are developed on the ventral surface and exposed directly to moisture, which is needed for the development and dehiscence. The male sex organs are developed earlier than the female sex organs, hence prothallus is protandrous. The sex organs are without any stalk and the male gametes are multiciliated. Now the sex organs. First the antheria. These are the male sex organs which develop and mature earlier than archegonia. These are small, sessile and globular structures. The antherial wall consists of 3 tubular celled jacket. These cells are the first ring cell that covers the basal portion of the antherial body, second ring cell that covers the middle portion of the antherial body, and the cap cell that covers the apical portion of the antherium. The cap cell forms a lid. Apart from these cells, there is a fourth cell at the base that can be considered as a single-celled stalk. The wall encloses 32 spermatocytes. Each one is metamorphosed into a long, spirally coiled, multiciliate, motile enterozoid. Dehiscence of the mature antherium takes place in the presence of water. The jacket cells and androcytes absorb water, swivel, and exert pressure, due to which the cap cell is either tilted upwards or thrown away. The enterozoids covered by endocyte membrane extrude out in massy. This extrusion is further assisted by the inward swelling and shortening of the wall cells. The membrane around the spermatozoids is dissolved and the male gametes become free to swim. Now the archegonia. The archegonia are developed later than antheria near to apical notch of the prothallus. It is flask-shaped with a swollen embedded venter in the prothallus and a projected short cylinder slightly curved neck. It has no ventral wall or jacket. It consists of a basal neck egg cell, above which is a small ventral canal cell. Neck consists of a single layered jacket with 4 vertical rows of cells, with each row having 4 cells. So, the total number of jacket cells is 16. The opercular cells or lid cells are absent. Anterior to the jacket of neck, a single dikaryotic neck canal cell is present. At maturity, the ventral canal cell and neck canal cell degenerate and form a sugary mucilaginous substance rich in malic acid. This substance exerts pressure at the distal end of archegonium, due to which the distal tire of neck cells is ruptured and the neck cells are far separated to establish a passage, and the substance comes out in the form of a droplet. The fertilization takes place in the presence of water between the lower surface of prothallus and soil. Malic acid of archegonial secretion helps in attracting the male gametes by chemotaxy. The male gametes enter the archegonium and one of the male gametes fuses with the egg to form the diploid zygote with its own wall. Fertilization is oogamous. Out of several archegonia of the prothallus, usually only one is fertilized. In some cases, even 2 or more archegonia may be fertilized. With act of fertilization, the growth of prothallus is arrested. The archegonial venter forms a cap-like calyptra around the fertilized egg. The zygote develops into an 8-celled embryo that later develops into the adult sporophyte. The first division in the zygote is vertical and forms 2 cells. The second division is also vertical but perpendicular to the first division to form 4 cells. The third division is transverse to form 8 cells. At this 8-cell stage, the embryo gives out the primary root from its lower tire region that pulses the calyptra and establishes contact with the soil. Later, the first leaf emerges through the apical notch of the prothallus. It turns green and performs photosynthesis. The shoot grows slowly to become an underground rhizome. At this stage, the primary root perishes, and in its place, many adventitious roots arise from the rhizome. Now, the life cycle of genus Pteris. The dominant stage in the life cycle of Pteris is the diploid independent sporophyte that produces spores in its sinusoid. The spores germinate and develop into the haploid gametophytic phase, the prothallus. The prothallus is highly reduced, short-lived, and independent. It reproduces sexually with the help of Antheridia and Archegonia, wherein are formed spermatozoids and egg cells, respectively. Fertilization of egg cell by a spermatozoid forms a diploid zygote, which develops into the normal sporophyte. Hence, the life cycle is diplohaploidic, since both gametophyte and sporophyte are morphologically different. Its alternation of generation is described as heteromorphic. We have discussed over here morphology, anatomy, and reproduction of genus Pteris. Dear students, we have also discussed life cycle of Pteris. Thank you very much. God bless you.
Good day, viewers. Today we will be discussing on cell in development. An essential property of every living cell is its capacity to develop into new cells or to undergo cell division, which not only inherits genetic material in the nucleus but also the cell organelles in the cytoplasm that are required for the expression of the genetic information. In cellular organisms, cell division simply forms a mode of reproduction. In multicellular organisms, cell division is responsible for embryonic development and growth in adult organisms. It is also involved in the repair of body tissues and in the regeneration of lost parts of the body. Cell division is essential part of both asexual and sexual reproduction. All cells follow a similar pattern of development for at least part of their lifespan. Cells first grow, then divide to produce two new cells. This is true of unicellular prokaryotic and eukaryotic organisms, and it is true of the cells that make up multicellular eukaryotic organisms. Cells grow by adding materials to their cell membranes and cell walls if present. They divide either by fission, as in prokaryotic organisms, mitosis or meiosis. The process of cell division is inherently intricate. Cells must partition their DNA and cell contents appropriately into the new cells that result from division. In addition, organisms need to control when and how often cell divide in order to develop properly and ultimately to survive. Types of cell division. Cell division is of two types, namely mitosis, the equational division, and meiosis, the directional division. Every cell that is capable of undergoing division has to pass through a cyclic sequence of events involving growth, synthesis, and division. These events collectively represent the cell cycle. It incorporates all the events that occur in a cell from the time that is formed newly from its parent cell till the time of its own division into daughter cells. Cell cycle has the following three main states. Interphase generally lasts at least 12 to 24 hours in mammalian tissues. During this method, the cell is constantly synthesizing RNA, producing protein, and growing in size. By studying motor events in cells, scientists have determined that interphase can be divided into four steps: gap 0, G0, gap 1, G1, S synthesis phase, and gap 2, G2. Karyokinesis. It is the phase of nuclear division. It involves separation of chromatids and their redistribution as chromosomes to the daughter cells. Cytokinesis. It is the phase of cytoplasmic division. It involves the distribution of cell organelles to the resulting daughter cells. Mitosis. This division is a very common type of cell division that occurs in all living cells in the body of an organism. Commonly, it is referred to as somatic cell division. The daughter cells resulting from mitosis will have the same number of DNA and same number of chromosomes as that of the parent cell. Hence, mitosis is described as equational division. Mitosis involves two major events, namely karyokinesis and cytokinesis. The division of the nuclear material involves a series of events which can be distinguished in four stages, namely prophase, metaphase, anaphase, and telophase. Prophase. It is the longest phase in mitotic division, characterized by the following significant events in the cell. Due to spiralization and condensation of the DNA molecule, the chromatids thicken and shorten. Centrioles start moving to the opposite poles of the cell. Each centriole develops radiating microtubules around itself to form an ester. Nucleus undergoes a gradual decrease in size and subsequently disintegrates. Nuclear membrane disappears. Microtubules develop into spindle fibers radiating between two esters. Metaphase. It is the shortest phase of mitosis, characterized by the chromosomes move towards the equator of the cell. Pairs of chromatids become attached to the spindle fibers at their respective centromeres. Anaphase. In this phase, rapid changes take place. In each chromosome, the centromere splits into two, separating the chromatids. Along with centromeres, the separated chromatids also get pulled to the opposite poles. Telophase. This phase features nuclear organization. After reaching the poles, the chromosomes change into chromatin due to uncoiling and lengthening of DNA. Esters lose their radiating fibers to become centrioles. Each centriole replicates. Spindle fibers disappear. A nucleolus reappears at each pole. A nuclear membrane is formed around the chromatin at each pole. Two daughter nuclei are formed. Cytokinesis occurs to divide cytoplasm and for distribution of cytoplasmic organelles to the future daughter cells. Significance of mitosis. Mitosis becomes significant for living organisms for following reasons. The daughter cell resulting from mitosis will be genetically identical to the parent cell since they contain same amount of DNA and chromosomes. Mitosis brings about an increase in the number of cells within an organism, and this process is called hyperplasia, which forms the basis of growth. Mitosis is the basis for asexual reproduction seen in plants and animals and vegetative propagation seen in plants. It is responsible for repair of the injured tissues and regeneration of the lost parts of the body. Now we discuss the second division, that is meiosis. Meiosis is a type of cell division which occurs only in the reproductive cells in sexually reproducing organisms. Hence, it is commonly known as the germ cell division. The data the mesoderm will become the cells of the connective tissue and cell function until a complete
पत्ते एकांत इसलिए इसे
Oxygen. The second one is proteins, which are the polymers of amino acids joined by peptide linkages. It contains carbon, hydrogen, oxygen, nitrogen, which are the polymers of monosaccharide unit. Today, we will discuss about the major macromolecules of life. In the present lecture, we will discuss about the 4 major macromolecules, the process of formation with their structure and function in detail. Macromolecules are large molecules formed by polymerization or the process of creating polymer chains out of the polymeric materials. Polymeric materials are formed when monomers are joined together by the dehydration reaction, whereas the same polymers can be broken down by the hydrolysis reactions. There are 4 fundamental types of macromolecules which are essential for the living organisms. They are carbohydrates, which are the polymers of monosaccharide units joined by the glycosidic linkage, and it contains carbon, hydrogen, and oxygen. The second one is proteins, which are the polymers of amino acids joined by peptide linkages. It contains carbon, hydrogen, oxygen, nitrogen, and sulfur. The third one is lipids, which are the polymers of fatty acid units joined by the ester linkages. It contains carbon, hydrogen, and oxygen. And the fourth one is nucleic acids, which are the polymers of nucleotide units joined by the phosphodiester linkages, and it contains carbon, hydrogen, oxygen, nitrogen, and phosphorus. Now let us discuss the given table which depicts the building blocks of macromolecules and its major functions. The building blocks of proteins, nucleic acids, carbohydrates, and lipids are amino acids, nucleotide monosaccharides, and fatty acids respectively. The major function of each of the macromolecules are proteins is essential for the fundamental basic structure and function of the cell. DNA, which functions as the repository hereditary information. RNA is essentially required for the protein biosynthesis. Carbohydrates help in the storage form of energy to meet the short-term demands. And lipids help in the storage form of energy to meet long-term demands and also forms the structural component of membranes. Now let us study the 4 fundamental types of macromolecules in detail. First macromolecule to be discussed is carbohydrates. They are most abundant organic molecules in nature. They are primarily composed of the elements carbon, hydrogen, and oxygen. The term carbohydrate was originally coined for this class of compounds as most of them were the hydrates of carbon or could be represented by the general formula CxH2OY. To accommodate a wide variety of compounds, the carbohydrates are nowadays broadly defined as polyhydroxyaldehydes or ketones and their derivatives as the substances that yield one or more compounds on hydrolysis. Functions of carbohydrates. They are the most abundant dietary source of energy, for example 4 calories per gram for all the organisms. They are precursors for many organic compounds like fats and amino acids. Carbohydrates like glycoproteins and glycolipids participate in the structure of cell membrane and cellular functions such as cell growth, adhesion, and fertilization. Carbohydrates also serve as the storage form of energy, that is glycogen, to meet the immediate energy demands of the body. Now, the classification of carbohydrates. They are usually classified in 3 groups. The first one is monosaccharides or monosaccharosis, where mono stands for one and saccharon stands for sugar. The monosaccharides, often called as simple sugars, are the compounds which possess a free aldehyde, that is CHO, or ketone, that is C double bond O group, or more hydroxyl, that is OH groups. They are in fact the simplest sugars and cannot be hydrolyzed into smaller units. Their general formula is CnH2nON. The monosaccharides may be subdivided into triosis, tetrosis, pentosis, hexosis, heptosis, etc. depending upon the number of carbon atoms they possess, and as aldosis or ketosis depending on whether they contain aldehyde or ketone group. Some important examples are given in table. The examples of aldose and ketose for the triose sugar are glycerose and dihydroxyacetone respectively. For tetrose sugar are erythrose and erythrulose respectively. For pentoses are ribose and ribulose. For hexose they are glucose and fructose, and for heptose they are glucoheptose and sedioheptulose respectively. The second major group is oligosaccharide or oligosaccharosis. As we all know, oligo means few, so these are the compound sugars that yield 2 or 10 molecules of the same or different monosaccharides on hydrolysis. Accordingly, an oligosaccharide yielding 2 molecules of monosaccharide on hydrolysis is designated as a disaccharide, and the one yielding 3 molecules of monosaccharide as a trisaccharide, and so on. The general formula of disaccharide is CnH2ON-1, and that of a trisaccharide is CnH2ON-2, and so on. A few examples are disaccharides like sucrose, lactose, maltose, cellobiose, trehalose, gentiobiose, mellibiose, etc. For trisaccharide it is raminos, gentianose, refinose, rabinose, melizitose, etc. And for tetrasaccharide it is stechiose, pentasaccharide it is verbascose, etc. The third category is polysaccharides or polysaccharosis. Poly means many and saccharose means sugar. So these are also compound sugars and yield more than 10 molecules of monosaccharides on hydrolysis. This may be further classified as homopolysaccharide or heteropolysaccharide. Homopolysaccharide are the compounds which yield only a single type of monosaccharides on hydrolysis. For example, starch, glycogen, inulin, cellulose, pectin, chitin. Whereas heteropolysaccharide are the compounds which yield a mixture of few monosaccharides or their derivatives on hydrolysis. For example, hyaluronic acid, chondroitin, heparin, dermatan sulfate, and keratin sulfate. Now let us discuss about the second macromolecule of life, that is proteins. They are the most abundant intracellular macromolecules with higher molecular weights and constitute over half the dry weight of most organisms. Proteins occupy a central position in the architecture and functioning of living matter. These are the polymers, that is chain-like molecules produced by joining a number of small units of amino acids called monomers. The amino acids are therefore regarded as building blocks of proteins. Functions of proteins. The first function is the structural functions. So these proteins are responsible for imparting strength to the body. It includes collagen and elastin found in the bone, vascular system and other organs. The second one is the dynamic functions. These proteins are known as acting proteins such as enzymes, hormones, blood clotting factors, immunoglobulins, membrane receptors, storage proteins that play an important role in genetic control, muscle contraction and respiration. Now let us discuss the classification of proteins. Proteins are divided on the basis of shape, composition and solubility. So the first classification to be discussed is on the basis of its shape. The first one is globular or corpuscular proteins. They possess relatively spherical or ovoid shape. They are usually soluble in water or in aqueous media containing acids, bases, salts or alcohol, and they diffuse readily. Nearly all the enzymes are globular proteins. Other examples are protein hormones, blood transport proteins, antibodies and nutrient storage proteins. The second to be discussed is the fibrous or fibrillar proteins. They possess long ribbons or fibers in shape. They are mainly of the animal origin and are insoluble in all common solvents such as water, dilute acids, alkalis and salts, and also in the organic solvents. Most fibrous proteins serve in the structural or protective role. It is a heterogeneous group and it includes the proteins of connective tissues, bones, blood vessels, skin, hair, nails, horns, hoof, wool and silk. The important examples are: number 1, collagen that form the major constituents of the bones. The second one is elastins that form the major constituents of ligaments and blood vessels. The third one is the keratin that form the major constituent of skin and hair. And the fourth one is fibroin that forms the major constituent of the silk fibers. The second to be discussed is on the basis of the composition and solubility. This is nowadays the most accepted system of classification and is based on the proposals made by the committees of British Physiological Society in 1907 and American Physiological Society in 1908. The system divides the proteins into 3 major groups based on their compositions, that is simple, conjugated and derived. So the first one is proteamines and histones. These are the basic proteins and occur almost entirely in all the animals, mainly in the sperm cells, soluble in water, unlike most other proteins, not coagulated by heat and strongly basic in character. Proteamines are virtually devoid of sulfur and aromatic amino acids. Histones are somewhat weaker bases and are therefore insoluble in ammonium hydroxide solution. Whereas the proteamines are soluble. For example, of some proteamines are clupine from herring sperm, celmine from salmon sperm, staurin from sturgeon, etc. The second one is albumins. These are widely distributed in nature but most abundantly found in seeds, soluble in water and dilute solutions of acids, bases and salts. Can be precipitated with a saturated solution of an acid salt like diammonium sulfate or a neutral salt like sodium sulfate and can be coagulated by heat. For example, leucosin in cereals, legumulin in legumes, ovalbumin from white of egg, serum albumin from blood plasma, myosin of muscles and lactalbumin from the milk whey. The third one to be discussed is globulins. These are of 2 types, pseudoglobulins and euglobulins. Euglobulins are more widely distributed in nature than the pseudoglobulins, either soluble pseudoglobulin or insoluble euglobulins in water. It can be precipitated with half saturated solution of diammonium sulfate, can be coagulated by heat, for example, pseudoglobulin, that is pseudoglobulin from milk whey. The examples of euglobulins are serum globulin from blood plasma, ovalbumin from egg white, myosinogen from muscles. Globulins of various plant seeds are like glycinin from soybean, leguminin from peas, amendin from peach, pomelin from oranges, and also tuberin from potatoes. The fourth to be discussed is glutelins. These have been widely isolated from the plant seeds, insoluble in water, dilute salt solutions and alcohol solutions, but soluble in dilute acids and alkalis and can be coagulated by heat. For example, glutenin from wheat, glutenin from corn, oryzinin from rice, etc. The fifth one to be discussed is prolamins. These have also been isolated only from the plant seeds, insoluble in water and dilute salt solution, but soluble in dilute acids and alkalis, and also in 60 to 80% of alcohol solution, cannot be coagulated by heat. For example, gliadin from wheat, zein from corn, and hodin from oat, etc. The sixth type is scleroproteins or albuminoids. These occur mostly entirely in all the animals and are therefore commonly known as animal skeletal proteins, insoluble in water, dilute solution of acids, bases, and salts, and also in 60 to 80% of alcohol solutions. And they are not attacked by enzymes, example, collagen of bones, elastin in ligaments, keratin in hair, tissues, and fibroin of silk. The third macromolecules to be discussed is lipids. The lipids are a heterogeneous group of compounds related to fatty acids and include fats, oils, waxes, and other related substances. These are oily or greasy organic substances relatively insoluble in water and considerably soluble in organic solvents like ether, chloroform, and benzene. These are variously called as lipins or lipoids. The term lipid was first used by the German biochemist Blohr in 1943 for a major class of tissue components and foodstuffs. Chemically, the fats are defined as the esters of glycerol and fatty acids, or as the triglycerides of fatty acids. The functions of lipids are: they are concentrated fuel reserve of the body, also known as triacyl glycerols. Lipids are constituents of membrane structure and regulate the membrane permeability. They are phospholipids and cholesterol. They serve as a fat-soluble vitamin like A, D, E, and K. They are important as cellular metabolic regulators, for example, steroid hormones and prostaglandins. Now let us discuss about the classification of lipids. Blohr in the year 1943 had proposed the following classification of lipids based on their chemical composition. The first type is simple lipids or homolipids. These are the esters of fatty acid with various alcohols. First one is fats and oils, also known as triglycerides or triacyl glycerols. These are the esters of fatty acids with a trihydroxy alcohol, that is a glycerol. The fat is solid at ordinary room temperature, whereas an oil is liquid at the room temperature. The second one is compound lipids or heterolipids. These are esters of fatty acids with alcohol and possess an additional group also. The first one is phospholipids, also known as phosphatids. These are the compounds containing phosphoric acid, nitrogen base, and other substituents in addition to fatty acids and glycerol. The second one is glycolipids, also known as cerebrosides. These are the compounds of fatty acids with carbohydrates and contain nitrogen but no phosphoric acid. The glycolipids also include certain structurally related compounds comprising the groups gangliosides, sulfolipids, and sulfatids. The third one is derived lipids. These are the substances derived from simple and compound lipids by hydrolysis. These include fatty acids, alcohols, mono and diglycerides, steroids, terpenes, and carotenoids.
The fourth macromolecule to be discussed is nucleic acids. The most important macromolecule imparting life to all the living cell is nucleic acid. The nucleic acids like DNA and RNA are the molecular repositories for genetic information and are jointly referred to as the molecules of heredity. The structure of every protein and ultimately of cell constituent is a product of information programmed into the nucleotide sequence of a cell's nucleic acid. Although the name nucleic acid suggests their location in the nuclei of the cell, but certain of them are also present in the cytoplasm. They are the macromolecules present in most living cells either in the free state or bound to the proteins as nucleoproteins. The classification of nucleic acids. There are two kinds of nucleic acid, that is deoxyribonucleic acid and ribonucleic acid. Both the types of nucleic acids are present in all the plants and animals. Viruses also contain nucleic acid. However, unlike a plant or animal, a virus has either RNA or DNA, but not the both. DNA is found mainly in the chromatin of the cell nucleus, whereas most of the RNA, that is around 90%, is present in the cell cytoplasm and a little of 10% in the nucleolus. It may be added that extracellular DNA also exists. It occurs, for example, in mitochondria or in chloroplast. Now, if we talk about RNA, then there are basically three types of RNA molecules. Number one is the transfer RNA, also known as the tRNA. The second one is the messenger RNA, also known as mRNA. The third one is the ribosomal RNA, also called as rRNA. Upon hydrolysis, under different set of conditions, the 2-nucleic acid yields three components. The first one is phosphoric acid, a pentose sugar, and a nitrogenous bases. The structural components of two types of nucleic acids, DNA and RNA, are discussed in the table. Now, the acid component of RNA and DNA is phosphoric acid, which is common. The pentose sugar of RNA is D-ribose, whereas of DNA it is D2-deoxyribose. The purine nitrogenous base of RNA and DNA are adenine and guanine, that is same, whereas the pyrimidine nitrogenous bases present in RNA are cytosine and uracil, whereas in DNA it is cytosine and thymine. Now, what are nucleosides? So these nucleosides are compounds in which nitrogenous bases, that is purines and pyrimidines, are conjugated to the pentose sugar, that is ribose or deoxyribose, by a beta glycosidic linkage. What are nucleotides? So nucleotides are the phosphoric acid esters of nucleosides. These occur either in the free form or as subunits in nucleic acids. The phosphate is esterified here with the sugar moiety. Purine and pyrimidine nucleotides fill a variety of metabolic roles. They are energy currency of the cell. In some cases, they are signaling molecules acting like hormones directly or as transducers of the information. They provide the monomers for the genetic information in the function of DNA and RNA. The two major functions of nucleic acids are transmission of hereditary characters, that is done by DNA, and synthesis of proteins, that is done by RNA. To summarize the importance of nucleic acid, let us discuss about the primary functions of each in brief. So the first one, if we talk about DNA, it is the storehouse of genetic information and it controls protein synthesis in the cell. For RNA, it directs the synthesis of specific proteins. mRNA, also known as messenger RNA, it helps in taking the genetic message from RNA. tRNA, that is transfer RNA, it transfers the activated amino acid to the site of the protein synthesis. And rRNA, that is ribosomal RNA, its functions are not clearly understood, but mostly they are present in ribosomes and are responsible for the stability of mRNA, that is messenger RNA. So to conclude the present discussion, we have learned that all the living organisms are dependent on four very large molecules essentially for their biological functions. These molecules are carbohydrates, proteins, lipids, DNA, and RNA. They are classified as biological macromolecules. Without DNA and RNA and proteins, all the forms of life could not exist. This is because each molecule plays an indispensable role in biology. Macromolecules constitute a major portion of the total dry weight of both eukaryotic and prokaryotic cells. They are responsible for all the most sophisticated functions of living cells, such as the catalysis of chemical reactions, the building of complex structures, the generation of movement, and the transmission of hereditary information. Macromolecules thus individually fulfill many distinct roles in the cell, and in addition, it works together in a large multimolecular complexes.
The botanical name of curry patta is Moraia koinijai. It is the member of the family Rutaceae, which includes plants like lemon, orange, elephant apple, and Moraia paniculata. Curry patta is a native of Sri Lanka, but is now found throughout India, the Nepal border, and the delta of Mahanadi under wild conditions. Moraia koinijai or curry patta can be propagated by branching or grafting. It is a shrub which is known with different names at different places throughout India, like meetha neem, kath neem, curry patta, or gandhela. The height of curry patta plant is 2 to 4 meters. The diameter of its stem is 14 to 40 centimeters. It is profusely branched and the pattern of branching is lateral. Its bark is grey to black in color. The leaf is compound. Leaflets are oval with dented margins. Each leaflet is 2 to 3 centimeters long and half centimeters in width. The flowering period of this plant is from July to September. The flowers are white, aromatic, and produced in bunches. The floral formula of curry patta is bracteate, regular bisexual. There are 5 calyx fused, 5 petals which are free stamen, in 2 rows of 5 plus 5, gynoecium, bicarpellary, syncarpus, ovary superior, bilocular, placentation, exile. Fruits are produced in bunches from October to December. They are subcircular with long stalks.
Other byproducts, egg, and alcoholic beverages. I shall be talking about the microbes that cause the contamination and the different ways by which we can prevent them or we can reduce it. These vegetables. There are different means by which these vegetables may be contaminated. They may include the aerosols, the bioaerosol falling on the leaves, they will contaminate with. But they have moderate food. In this particular lecture, I shall be talking about different aspects of contamination in vegetables, fruits, milk and other dairy products, cereals and different other byproducts, egg and alcoholic beverages. I shall be talking about the microbes that cause the contamination and the different ways by which we can prevent them or we can reduce it. To start with, vegetables are basically crops which contains mostly water, and they are of course leafy or sometimes non-leafy in nature, but they have moderate to low percentage of carbohydrate and protein. That means 8.6% of carbohydrate, protein is around 2%, fat is very low, mineral is also relatively higher, and also there may be other elements present in these vegetables. There are different means by which these vegetables may be contaminated. They may include the aerosols, the bioaerosol falling on the leaves, they will contaminate with bacteria, or it may come from the different seeds which are contaminated with bacteria, or it can come from soil entering the crop plants through their root, or sometimes it can be with the water, or even it can be with the agricultural equipment which we use. And of course, there may be the insect vectors which can cause the damage to these crops, and these bacteria and virus can enter, and they remain inside the vegetable crops. There may be different types of organisms that normally contaminate the vegetables, which may include the gram-positive like the Enterococcus, the gram-negative like the Escherichia coli, the yeasts like the Candida or Debromyces, or even it may include the molds like Aspergillus, Penicillium, Fusarium, Geotrichium, etc. And they are all developing inside the vegetable or on the surface and may have more than one organism at a time. As for example, if we consider some specific diseases, one such disease is the soft rot of vegetables. This vegetable crop or the leafy crop will be invaded by a bacteria called Arvinia. And this Arvinia, these are the bacterial cells which will enter through the gap in the cuticle and will be entering into the subepidermal cell and will form colony and reproduce over there and may remain for a longer period. But soft rot at the end of the day may also be caused by physiological deficiency, and it is actually the polygalacturonase activity. If it is too high, then naturally the rotting is very faster. So naturally, if there is by any means we can reduce the activity of these enzymes, polygalacturonase or hydrolase or pectinase, if we can reduce it, then naturally the shelf life of the crop can increase. Based on this particular principle, the flavor saver tomato was developed, which had a longer shelf life than other tomato variety. Coming to the infection of molds. Now normally the molds are invading the leaf surface. These are the colonies of molds on the mustard leaf, and sometimes these mold spores are transmitted through fruit fly or Drosophila. But once inside the epidermal surface, they will grow inside into the cortex and produce conidia. And this conidia will germinate, produce a mycelial mesh inside, and then they are cut up by the air and come out and produce thick-walled spore called sclerotia. In this particular condition, they may remain for some time. That means they may overwinter and again invade another crop plant. So this is the cycle. We call it summer cycle and winter cycle. But at the end of the day, the quantum of disease develop inside the crop. Here it is bean or broad bean. Now, as a matter of fact, I told you that there are different ways by which these contaminating organisms may come, and they include the soil, they include the manure, they include the fertilizer. Along with this particular contaminants, what is important, it may also induce pollution, and general pollution can also induce physiological stress in the crop plant. So basically, this mechanized harvesting may reduce the disease, but at the same time, while harvesting the crop, there may be some damages, and so the crop is harvested, but there is some injury through which the bacteria and fungi will enter and will come into the human gut through these vegetables. So that is not also good. A very important factor is proper storage, because if you can store it properly, then naturally this particular contaminating bacteria and fungi will be low, and this type of plastic containers, which is not allowing any air, might reduce the aerobic organisms. Of course, there may be threat of anaerobic ones. So basically, if we can be more careful in harvesting the crop, in processing it and in storing these particular crops, the contamination of vegetables can be removed or reduced to a remarkable extent. Now coming to fruits, which are close to vegetables, but their percentage of water may vary. It may be around 85%. Carbohydrate content may be higher because of high sugar content, 13%. Protein is almost the same, that is around 1%. Fat is low, 0.5%. And ash content and mineral content is also low. But what is important, sometimes these fruits, they do have organic acids like malic acid, like citric acid, and so naturally the pH is low. And in this particular lower pH, the acidophilic organisms can grow and can contaminate the fruit. A very important example of fruit is banana. Now banana normally is invaded by different species of yeast. And whenever we take it, we always do consume this yeast, but because they are not that much harmful, we don't face the problem. But when it comes to maize, this maize is contaminated with penicillium, and actually this particular disease is blue rot because the spores are blue in nature. If it is in case of penicillium, there is no harm because there may be antibiotics produced like penicillin. But if it is aspergillus, which is black rot, there may be the aspergillus toxin or aflatoxin, which is cancerous. So there lies the problem. Or sometimes it may come as, in broad bean. This is a broad bean where there is a infection of downy mildew, and this downy mildew is nothing but the spores of Phytophthora. So apparently we consider these beans might have some dust, but actually it is fungal spore which we take in if we are not cleaning it properly. This is a very common picture where you can see aspergillus spores, the black spores of aspergillus growing on onion, and very often it can come into our gut and may impose problems of aflatoxin. So it is a black rot. This is a peach fruit which is invaded by Geotrichium, and these are the Geotrichium colonies which has created soft depressed areas, and this particular contaminated peach is not good for our intestine. So how can it be prevented? It can be prevented in the early harvesting. If we keep the fruit little bit in the refrigerator or refrigerated condition, these microbes can be less. And at the same time, if we take enough care about harvesting it, the damage will be less, so later contamination can be reduced. Now coming to the next part, which is the milk and milk product. Now milk primarily is contaminated through infection of the udder of the cow. And it can also come from the equipment, it can also come from the contaminated hands of the milkman. So basically human interference to a great extent is responsible for contamination in milk and milk product. And one such important contaminant is the Pseudomonas. These are the Pseudomonas bacteria or Pseudomonas bacteria coming from the udder in the milk. It may also include the gram-positive bacillus, which is also causing infection in the cow as seen in the udder. These are the udder infection caused by bacillus. But when it comes to Pseudomonas aeruginosa, it actually can cause carding of milk. So this carding is not good. This card is poisonous because if it is not contaminated, then this card is good because it has lactobacillus. But if it is Pseudomonas causing carding as seen here, then it is bad for the gut or bad for the intestine or may cause loss of water in the form of diarrhea. Now, very commonly, human interference can cause infection of the milk, and they include the Staphylococcus, Bacillus, Micrococcus, Klebsiella, Serratia, Streptococcus, and mind you, all these bacteria mostly comes from human hand. So basically, if we can clean our hand before milking or before processing milk, to a great extent, this bacterial contamination can be prevented. Pasteurization can prevent bacterial infection or bacterial contamination, but pasteurization does not prevent the endospores, and these endospores may remain in the pasteurized milk sample, causing destruction of the milk. One important byproduct of milk is butter, and butter actually is spoiled by this organic acid produced by Pseudomonas, which is called isovaleric acid. And this isovaleric acid is produced by the Pseudomonas petrifaciens, which is also isolated from butter, and it causes degradation of fat, we call it lipolysis, and it increases the rancidity, and this rancidity increases in this tropical temperature, which might be low when the temperature is less. That means refrigerated condition storage is very important for butter or butter products, and this will prevent this rancidity of butter caused by Pseudomonas fagi. Now coming to the very important product, milk product, which is the cheese. Cheese can be cottage cheese. A common experience is the infection of alkaligens, which is producing a slimy layer on the cheese. We call it slimy card. Of course, this slimy card can be removed, but that doesn't mean we have removed all the bacteria. And when it comes to alkaligens apparently will not cause severe infection, but may cause stomach upset when it is inside human body. Clostridium butyricum is present in ripened cheese, and it produces butyric acid, which is reducing the pH and harmful for the gut or intestine. Ghee is another milk product, which is also contaminated by mold, and it changes the texture. And this mold can easily be prevented through proper packaging or storage. Ice cream, we all like it, but have we ever thought that the ice cream container, if proper hygienic condition is not maintained, will contain different bacteria, and that also includes salmonella, causing stomach upset or food poisoning? Sometimes we like this processed ice cream called fried ice cream, but the oil with which this particular ice cream is fried may contain Pseudomonas, may contain salmonella, and they are the probable source of bacteria in ice cream. Now we come to another important food product, which is egg. Apparently, when we see the egg, we do not really see minute cracks, but if these cracks are there, then naturally these cracks will allow the entry of bacteria like salmonella, and they will spoil the egg, which is definitely harmful for us, and it may also contain Cladosporium spore, which is also causing stomach upset. So basically, when we buy the egg, we should be careful enough that there is no hair crack or there is no minutest crack in the egg shell. Now coming to different bread products, cereals. The bakery products, they do produce bread which may be contaminated by mucor. This is quite apparent that the mucor sporangia is easily seen, but sometimes it is not seen. We call it ropey bread. Ropey bread is caused by bacteria like Bacillus subtilis or Bacillus licheniformis, which we don't see, but when we consume it, there will be food poisoning. And these are the bacillus which is obtained from bread, causing ropiness of the bread. And mind you, bacteria may be there, but if it is only present in certain concentration, the infection will be there. In this case, we call it 10 to the power 7 CFU or colony-forming unit, like these units. If it is there in this particular percentage, there will be infection of bacteria. Sour bread, apparently sour bread, because of low pH, bacterial concentration will be less, but there may be yeast contamination in sour bread, or there may be sometimes lactobacillus growing in sour bread coming to our intestine. Cakes which we prepare from milk, flour, and also egg may be contaminated by bacteria. And this bacterial contamination will change the texture, which also include the Pseudomonas. Biscuits, which are bakery products, apparently it is produced from the bakery, it will not have any contamination, but because of poor storage, because of insect vector like this cockroach, there will be bacterial contamination. How to prevent this contamination? Preventing this contamination is rather easy. We have to store it in low moisture. We have to have some mechanized, non-human interfering mechanism by which these foods are processed and stored. And at the same time, we must be careful about the expiry date as per the FAO license. If it is too close to expiry, we should not buy it, even if the package is alright or intact. Now coming to the next important aspect, which include the different alcoholic beverages, and these alcoholic beverages include beer, wine, etc. One important source of contamination is lactobacillus. There may be organic acid producing gluconobacter, acetobacter, and this yeast species called Megasphaera cerevisiae. And they apparently will be there in the bottle because they can tolerate the glycerol stress or low pH, and they will be present in beer, and if we consume this spurious beer, there will be loose motion or stomach upset. Of course, this can be prevented through proper processing, and this include the microbial quality check. What is done? It is normally through gram staining or through the testing of catalase and also the testing of fermentation ability. We can detect each and every individual contaminating species, which include the lactobacillus, which include the streptococcus, which include the leuconostoc. So all these contaminating species can be separated and characterized before the alcoholic beverage is bottled. And that is very important for a brewery in order to maintain standard of its alcoholic beverage. Coming to wine, wine actually may be contaminated by mold because very often wine is prepared in households and they may contain aspergillus or penicillium and they may be there in the bottle and they can tolerate that acidic pH. And another important household product is the pickle. This pickle may be contaminated by mold or fungi or even bacteria, which is already there in the fruit from where, or the vegetable from where the pickle is made, and because of poor storage, this bacteria will grow. And what is the remedy then? The most common remedy is to ensure the quality of the product which we produce and increase the amount of preservative, maybe through acetic acid, because acidic pH will reduce all these contaminating organisms. In conclusion, we can say that microbes are present everywhere. Bacterial spores, fungal spores are present in air, and they may contaminate different fruits, vegetables, milk product, even alcoholic beverage. So what we should do to prevent it? We should reduce this contamination either through proper processing, proper storage, and of course, minimizing human intervention, because these are dirty hands which contains different bacteria, different fungal spore, which we don't see, but apparently when they are coming into food material, they will contaminate it. So we have to reduce this intervention in order to produce good quality, macro-free food material. Thank you.
It was not a mere cliché when poets like Wordsworth and Shelley gave a call to go back to nature. They realized that evolution of man owes a lot to flora and fauna. The trees not only sheltered the aborigine from wild animals, but also gave him fruits. With the first planted seed cropping up, his nomadic days turned into settled ones of agriculture and civilization. With the ever-complex evolution of man, his expectations from the plant kingdom also grew multifarious. He worked at identifying plants with multiple qualities. Some plants had medicinal properties and could be used to cure diseases. flowers rich in fragrance could be used for making perfumes. The richer he found nature, the sharper did man become in putting things to good use. One such useful plant identified by man is henna. The leaves of henna possess coloring properties, because of which it is used the world over to color the skin, hair, nails, feet, hands, and even textiles.
Many beliefs are attached with the history of henna plant. It is believed that the art of using henna paste for decoration dates as far back as 3000 BC. The ancient Egyptians applied henna to their nails and feet. To all beauty-conscious Indians, such application is known as mehendi. From Egypt and other African countries, the art of mehendi spread to the Middle East. It was either the Persians or the forerunners of Mughal Empire around 1500 AD who brought this art to India. Traces of henna have been found on mummies as early as 1200 BC. It has also been ascertained that prior to mummification, hands and feet of pharaohs were first dipped in henna. It can safely be concluded that with the progress of human civilization, mehendi became an integral part of cultural traditions of various countries the world over.
In a country of festivals and rituals, mehendi did not take long to fashion a unique place of its own in Indian customs and traditions. A mark of tenderness and joy, it is not bound by custom or occasion alone. It is an integral part of the wedding ceremonies and is almost synonymous with the exalted status of a bride. Botanically, the henna plant is known as Lawsonia inermis and belongs to the family Lythraceae. Another member of this family is pomegranate. Actually, the henna plant is a native of North Africa, Asia, and Australia. It is cultivated in the tropics of America, Egypt, India, and parts of the Middle East. It is also known as mehendi, al-henna, Egyptian privet, and minnonet tree. The henna plant is a smooth and shiny, profusely branched shrub with greyish-brown bark. Its branches terminate into pointed spines. The leaves are opposite, subsessile, elliptic, entire, acute, or obtuse. They are 2 to 3 centimeters long and 1 to 2 centimeters wide. The leaves are fleshy, because of which the midrib can be clearly seen, but the secondary veins are not visible. They contain soluble matter, lawsone, 2-hydroxy-1,4-naphthaquinone, tannin, gallic acid, glucose, mannitol, fat, resin, and mucilage. Reaching a height of about 1 to 3 meters, this plant has numerous white or rose-red colored small flowers. It has a cymose inflorescence. The bunch of flowers form the shape of a pyramid. Flowers possess a pleasant aroma, because of which honeybees and insects can be seen buzzing around them. The distillation of these flowers produces 0.01 to 0.02% brown-colored oil. The fragrance of this oil is said to resemble the smell of tea rose and mignonette. Crude perfumes are also produced from the flowers. The flowers are ebractate, tetramerous, epigynous, and regular. 4 persistent calyx are fused with the fruits. The 4 free petals are wrinkled and white or cream in color. Stamens are in 4 pairs, and the anthers are dorsifixed, that is fixed on the back. The gynoecium is tetracarpellary, syncarpous. Ovary is superior, tetralocular, with exile presentation. The floral formula of the henna plant can be represented as. The floral diagram can be represented as. Each chamber of the ovary contains several ovules, which produce numerous seeds on fertilization. An analysis of the seeds reveal that they contain 10.06 moisture, 5% protein, 10 to 11% fat, 33.62% carbohydrates, 33.55% fibers, and 4.75% ash. The fruit of henna plant is a dry and dehiscent brown-colored capsule having a permanent style. The henna plant can be grown in any kind of soil, but it mostly prefers loam soil, which is rich in moisture. It is grown through cuttings and seeds. Henna today is planted primarily as an ornamental hedge, but is probably best known for its dried, ground leaves, called henna, traditionally used to produce color-fast orange, red, and brown dyes. The dried, powdered leaves of henna contain about 0.5 to 1.5% lawsone or henoteinic acid, the chief constituent responsible for dyeing properties of the plant. Molecules present in the henna powder have a chemical affinity with keratin molecules, and thus the pigment can freely pass into the hair. As a result, the leaves of henna have been used in Asia since antiquity as a hair, nail, and skin dye. The principal advantage offered by henna as a modern hair colorant is its eco-friendly nature, because of which it is a safe coloring agent than compared to some harmful chemical dyes.
The story of how mehendi came into vogue in northwestern India is quite interesting. It is believed that the practice started because of henna's ability to cool. When heat-sick people in the arid deserts of Rajasthan and Gujarat discovered this property, they dipped their hands and feet in a mud paste made with crushed henna leaves. On scraping off the mud, they noticed that as long as the color remained visible, their body temperature stayed low. Eventually, it was found that small dots placed in hands had the same effect. Stimulated by this, intricate lacy lines and creative designs of flowers and birds began to adorn the human limbs.
In the West and the Middle East, henna is used in hair shampoos, dyes, conditioners, and rinses. Extracts of henna are used to stain wood and to dye fabric and textiles. Apart from this, the henna plant also possesses medicinal properties. It has been used for astringent, anti-hemorrhagic, intestinal problems, cardio-inhibitory, hypotensive, and sedative effects. It has also been used as a folk remedy against hemiptysis, headache, jaundice, and leprosy. Henna extracts also possess antibacterial, antifungal, and ultraviolet light screening properties. Traditionally, henna has also been used as a healing ointment to treat burns, ulcers of the mouth, and treatment of smallpox in its early stages. The wood of this plant is hard, containing compact grains, and is used to make handles for various instruments.
A plant that decorates, cures many ills, and serves as a utility timber. Where else would one find such varied qualities in a single plant? Who would not be tempted to grow a henna plant around his house? For the down-to-earth people who hold beauty in contempt as being skin deep, henna can still be useful, if not as an aid to personal embellishment, but at least as an ornamental hedge to safeguard their houses.
Hello students, today's class is on buffers. Coming to introduction. Buffers are aqueous systems that tend to resist changes in pH when small amount of acid like hydrogen ion or base like hydroxyl ion are added. A buffer system consists of a weak acid as a proton donor and its conjugate base as a proton acceptor. The normal range of pH in human blood plasma is between 7.35 and 7.45, and many of the enzymes that function in the blood have evolved to have maximum activity in that pH range. Many aspects of cell structure, function, and the catalytic activity of enzymes is especially sensitive to pH. Enzymes typically show maximum catalytic activity at a characteristic pH called the pH optimum. On either side of this optimum pH, the catalytic activity often declines sharply. Thus, a small change in pH can make a large difference in the rate of some crucial enzyme catalyzed reactions. The imbalance in acid-base buffering system in our body can lead to conditions like acidosis or alkalosis. Biological control of the pH of cells and body fluids is therefore of central importance in all aspects of metabolism and cellular activities, and changes in blood pH have marked physiological consequences. Coming to the role of buffer in resisting pH change. Let us take an example and compare the changes in pH that occur on the addition of equal amounts of strong acid or strong base to pure water at pH 7 and to a buffer solution at pH 7. If 1 ml of 0.1 molar HCl is added to 99 ml of pure water, the pH drops drastically. If the same experiment is conducted with 0.1 molar sodium hydroxide instead of 0.1 molar HCl, the pH rises drastically. But when buffer solution is used instead of pure water, the results are different. A solution that contains the monohydrogen phosphate and dihydrogen phosphate ions in suitable proportions can serve as proton acceptor or donor and serve as a buffer. Many biological reactions will not take place unless the pH remains within fairly narrow limits, and as a result, buffer compared to its pKa, we can select an appropriate buffer. For example, if we were doing an experiment and
लेकिन इसके साथ ही रात
8 से 20 सेंटीमीटर तक लंबे तथा पानीवत होते हैं। पत्ती के किनारे दांताकार यानी दांतों के आकार के होते हैं। पत्ते में लचीला शीर यानी लेटेक्स होता है, जिसमें सिट्रॉल, लिनोलोइल एसिड
प्रक्रिया की जानकारी लेते हैं।
करीब 10 दिन तक पत्ते खाने के बाद इल्ली का रूपांतर प्यूपा में हो जाता है। यह रेशम के कीड़े की विश्राम अवस्था है। प्यूपा अपनी सुरक्षा के लिए लार के रूप में रेशेदार प्रोटीन स्रावित करता है। यह लार ही रेशम है। प्यूपा के चारों ओर रेशम का आवरण ककून कहलाता है। ककून हल्के पीले या सफेद रंग का होता है। यही रंग हमें बाजार के रेशम के कपड़ों में दिखाई देता है। ककून ही रेशम का स्रोत है। प्रत्येक ककून में लगभग 800 से 1000 मीटर तक रेशम का रेशा होता है। ककून बनने में 6 से 7 दिन लगते हैं। ककून को उबले पानी में डालकर धागा अलग किया जाता है। इस क्रिया में कीट मर जाता है, अन्यथा प्यूपा से पतंगा बन जाएगा जो ककून को तोड़कर बाहर निकलता है। लेकिन इस प्रक्रिया में धागा नष्ट हो जाता है। कुछ ककून परिपक्व होने के लिए छोड़ दिए जाते हैं। इनमें से 5 दिन बाद पतंगा निकलता है। रेशम के कीड़े का जीवन चक्र पूर्ण होने में 25 से 28 दिन लगते हैं। बाजार में मिलने वाला रेशम वास्तव में रेशेदार प्रोटीन ही है, जो समृद्धि तथा शान शौकत का प्रतीक माना जाता है। शहतूत टहनियों द्वारा उगाया जा सकता है। धीमी वृद्धि के कारण इसका जीवन काल अधिक होता है। इसे शुष्क स्थानों पर भी लगाया जा सकता है। इसे ना तो अधिक पानी की आवश्यकता होती है, ना ही उर्वरक की। यह हमें मीठे फलों के साथ ही कीमती रेशमी कपड़ों के लिए धागा भी उपलब्ध करवाता है। और भला रेशम किसे पसंद नहीं होगा?
हमें ये नहीं भूलना चाहिए कि अन्य पौधों की तरह ही शहतूत लगाने से भी आसपास के स्थानों की सुंदरता बढ़ती है। एक पौधा और उसे इतने फायदे। इसलिए यदि हम आकार को भूलकर सिर्फ स्वाद की तरफ ध्यान दें, तो निश्चित ही शहतूत के स्वादिष्ट फल तपती दोपहर की गर्मी को एक मीठे और शीतल एहसास में बदल देंगे।
Hello everyone, welcome to a new session on informatics and introduction to bioinformatics. Overview of information technology, part 4, operating systems. The operating system is the most important program that runs on a computer. Operating systems perform basic tasks such as recognizing input from the keyboard, sending output to the display screen, keeping track of files and directories on the disk, and controlling peripheral devices such as disk drives and printers. An operating system is a program that acts as an intermediary between a user of a computer and the computer hardware. The purpose of an operating system is to provide an environment in which a user can execute programs. Operating systems are there from the very first computer generation. A computer system can be divided roughly into 4 components: the hardware, the operating system, the applications programs, and the users. A more common definition is that the operating system is the one program running at all times on the computer, usually called the kernel, with all else being applications programs. You've probably heard the phrase boot your computer, but do you know what that means? Booting is a process that occurs when you press the power button to turn your computer on. During this process, the computer does several things. It runs tests to make sure everything is working correctly. It checks for new hardware. It then starts up the operating system. Once the operating system has started up, it manages all of the software and hardware on the computer. Most of the time, there are many different programs running at the same time, and they all need to access your computer's central processing unit, or CPU, memory, and storage. Operating system types. Following are few of the important types of operating systems which are most commonly used. Batch operating system. The users of batch operating system do not interact with the computer directly. Each user prepares his job on an offline device like punch cards and submits it to the computer operator. To speed up processing, jobs with similar needs are batched together and run as a group. Thus, the programmers left their programs with the operator. The operator then sorts programs into batches with similar requirements. The problems with batch systems are lack of interaction between the user and job. CPU is often idle because the speeds of the mechanical input-output devices is slower than CPU and difficult to provide the desired priority. For example, batch processing is a way that credit card companies process billing. The customer does not receive a bill for each separate credit card purchase, but one monthly bill for all of that month's purchases. The bill batch processing, where all of the data are collected and held until the bill is processed as a batch at the end of the billing cycle. Batch processing is also often used to perform various operations with digital images such as resize, convert, watermark, or otherwise edit image files. It may also be used for converting computer files from one format to another. For example, a batch job may convert proprietary and legacy files to common standard formats for end-user queries and display. Time-sharing operating systems. Time-sharing is a technique which enables many people located at various terminals to use a particular computer system at the same time. Time-sharing or multitasking is a logical extension of multi-programming. Processor's time, which is shared among multiple users simultaneously, is termed as time-sharing. Multiple jobs are executed by the CPU by switching between them, but the switches occur so frequently. Thus, the user can receive an immediate response. It will provide advantage of quick response. It can avoid duplication of software and also reduce CPU idle time. Disadvantages of time-sharing operating systems are question of security and integrity of user programs and data. It also causes the problem of data communication. For example, a mainframe computer that has many users logged onto it. Each user uses the resources of the mainframe, that is, memory, CPU, etc. The users feel that they are exclusive user of the CPU, even though this is not possible with one CPU that is shared among different users. The following operating systems are best examples for time-sharing systems. Multics, Unix. Distributed operating system. Distributed systems use multiple central processors to serve multiple real-time applications and multiple users. Data processing jobs are distributed among the processors accordingly to which one can perform each job most efficiently. The processors communicate with one another through various communication lines such as high-speed buses or telephone lines. These are referred as loosely coupled systems or distributed systems. Locus and micros are the best examples of distributed operating systems. Using locus operating system, it was possible to access local and distant files in uniform manner. This feature enabled a user to log on any node of the network and to utilize the resources in a network without the reference of his or her location. Micros provided sharing of resources in an automatic manner. The jobs were assigned to different nodes of the whole system to balance the load on different nodes. Network operating system. Network operating system runs on a server and provides server the capability to manage data, users, groups, security, applications, and other networking functions. The primary purpose of the network operating system is to allow shared file and printer access among multiple computers in a network, typically a local area network or LAN, and a private network or to other networks. Examples of network operating systems are Microsoft Windows Server 2003, Microsoft Windows Server 2008, Unix, Linux, Mac Operating System X, Novell NetWare, and BSD. Real-time operating system. Real-time system is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. Real-time processing is always online, whereas online system need not be real-time. The time taken by the system to respond to an input and display of required updated information is termed as response time. So, in this method, response time is very less as compared to the online processing. As a user, you normally interact with the operating system through a set of commands. For example, the DOS operating system contains commands such as copy and rename for copying files and changing the names of files respectively. The commands are accepted and executed by a part of the operating system called the command processor or command line interpreter. Graphical user interfaces allow you to enter commands by pointing and clicking at objects that appear on the screen. An early example of a large-scale real-time operating system was transaction processing facility developed by American Airlines and IBM for the Sabre airline reservation system. Currently, the best known, most widely developed real-time operating systems are QNX, RT Linux, VxWorks, Windows CE. Microsoft makes the Windows operating system used in many computers. The operating system is a set of instructions that tells your computer how to run and how to manage the different programs that you install. There are several versions of Windows currently in use, including Windows 95, Windows 98, Windows XP, Windows Vista, and Windows 7. The newest version of the Windows operating system is called Windows 8. They include from most recent to the oldest. Windows 8. Windows 8 is a version of Microsoft Windows, which is an operating system developed by Microsoft for use on personal computers including home and business desktops, laptops, tablets, and home theater PCs. Development of Windows 8 started before the release of its predecessor, Windows 7, in 2009. It was announced at the CES 2011 and followed by the release of 3 pre-release versions from September 2011 to May 2012. The operating system was released to manufacturing on August 1, 2012 and was released for general availability on October 26, 2012. Windows 8 introduces significant changes to the operating system's platform, primarily focused towards improving its user experience on mobile devices such as tablets to better compete with other mobile operating systems like Android and Apple's iOS. It features a new touch user interface and shell based on Microsoft's Metro design language, featuring a new start screen with a grid of dynamically updating tiles that represent applications. The start screen replaces the start menu of earlier Windows versions. There is a new application platform with an emphasis on touchscreen input and the new Windows Store to obtain and/or purchase applications to run on the operating system. Windows 7. Windows 7 is an operating system produced by Microsoft for use on personal computers, including home and business desktops, laptops, netbooks, tablet PCs, and media center PCs. It was released to manufacturing on July 22, 2009 and became generally available for retail worldwide on October 22, 2009, less than 3 years after the release of its predecessor, Windows Vista. Windows 7 Server counterpart, Windows Server 2008 R2, was released at the same time. Windows 7 is succeeded by Windows 8. Windows Vista. Windows Vista is an operating system. It was released by the Microsoft Corporation in late 2006, which comes in several versions, such as Home Basic, Home Premium, Business, Ultimate, and Enterprise. The features available to you depend on the version of Windows Vista you have. It Enterprise for large global organizations and is only available to organizations with desktops covered by software assurance agreements or organizations with a Microsoft Enterprise agreement that includes the Windows desktop component. The release of Windows Vista came more than 5 years after the introduction of its predecessor, Windows XP, the longest time span between the successive releases of Microsoft Windows desktop operating systems. Windows XP Professional Edition is a version used by many businesses on workstations. It has the ability to become a member of a corporate domain. Windows XP Home Edition. This is a low-cost version of Windows XP, which is for home use only and should not be used at a business. Windows 2000. A better version of the Windows NT operating system, which works well both at home and as a workstation at business. It includes technologies which allow hardware to be automatically detected and other enhancements over Windows NT. Windows ME, an upgraded version from Windows 98, but it has been historically plagued with programming errors which may be frustrating for home users. Windows 98. Windows 98 was produced in 2 main versions. The first Windows 98 version was plagued with programming errors, but the Windows 98 second edition, which came out later, was much better with many errors resolved. Windows NT, a version of Windows made specifically for businesses offering better control over workstation capabilities to help network administrators. Windows 95, the first version of Windows after the older Windows 3.x versions, offering a better interface and better library functions for programs. There are other worthwhile types of operating systems not made by Microsoft. The greatest problem with these operating systems lies in the fact that not as many application programs are returned for them. However, if you can get the type of application programs you are looking for, one of the systems listed below may be a good choice. Unix, a system that has been around for many years and it is very stable. It is primarily used to be a server rather than a workstation and should not be used by anyone who does not understand the system. It can be difficult to learn. Unix was normally run on a computer made by the same company that produces the software. Linux. Linux is similar to Unix in operation, but it is free. It also should not be used by anyone who does not understand the system and it can be difficult to learn. Apple Macintosh. Most recent versions are based on Unix, but it has a good graphical interface, so it is both stable and easy to learn. One drawback to the system is that it can only be run on Apple-produced hardware. Major application software. Application software consists of programs that direct computers to perform specific information processing activities for end users. These programs are called application packages because they direct the processing required for a particular use or application which users want to accomplish. Thousands of application packages are available because there are thousands of different jobs end users want computers to do. Application software includes a variety of programs that can be subdivided into general purpose and application-specific categories. General purpose application programs. General purpose application packages are programs that perform common information processing jobs for end users. For example, word processing programs, electronic spreadsheet programs, database management programs, graphics programs, communication programs, and integrated packages are popular with microcomputer users for home, education, business, scientific, and many other general purposes. They are also known as productivity packages because they significantly increase the productivity of end users. This packaged software is also called off-the-shelf software packages because these products are packaged and available for sale. Many features are common to most packaged programs. Application-specific software. Many application programs are available to support specific applications of end users. Business application programs. Programs that accomplish the information processing tasks of important business functions or industry requirements. Scientific application programs. Programs that perform information processing tasks for the natural, physical, social, and behavioral sciences, engineering, and all other areas involved in scientific research, experimentation, and development. There are so many other application areas such as education, music, art, medicine, etc. Application programs are written in a text-based computer language. Once written, they compile into a binary language the computer understands. The application programs use function calls to interface to the various computer peripherals such as your keyboard, mouse, screen, printers, and other devices. Popular application software. Application software utilizes the capacities of a computer directly for a dedicated task. Application software is able to manipulate text, numbers, and graphics. It can be in the form of software focused on a certain single task like word processing, spreadsheet, or playing of audio and video files. Here, we look at the application software types along with some examples of application software of each type. Different types of application software. Word processing software. This software enables users to create and edit documents. The most popular examples of this type of software are MS Word, WordPad, and Notepad, among other text editors. Database software. Database is a structured collection of data. A computer database relies on database software to organize data and enable database users to perform database operations. Database software allows users to store and retrieve data from databases. Examples are Oracle, MS Access, etc. Spreadsheet software. Excel, Lotus 123, and Apple Numbers are some examples of spreadsheet software. Spreadsheet software that allows users to perform calculations using spreadsheets. They simulate paper worksheets by displaying multiple cells that make up a grid. Multimedia software. They allow users to create and play audio and video files. They are capable of playing media files. Audio converters, audio players, burners, video encoders and decoders are some forms of multimedia software. Examples of this type of software include Real Player and Media Player. Presentation software. The software that is used to display information in the form of a slideshow is known as presentation software. This type of software includes three functions, namely editing that allows insertion and formatting of text, methods to include graphics in the text, and a functionality of executing slideshows. Microsoft PowerPoint is the best example of presentation software. Enterprise software. It deals with the needs of organization processes and data flow. Customer relationship management or the financial processes in an organization are carried out with the help of enterprise software. Information worker software. Individual projects within a department and individual needs of creation and management of information are handled by information worker software. Documentation tools, resource management tools, and personal management systems fall under the category of this type of application software. Educational software. It has the capabilities of running tests and tracking progress. It also has the capabilities of collaborative software. It is often used in teaching and self-learning. Dictionaries like Britannica and Encarta, mathematical software like MATLAB, and others like Google Earth and NASA Worldwind are some of the well-known names in this category. Simulation software. Simulation software is used to stimulate physical or abstract systems. Simulation software finds applications in both research and entertainment. Flight simulators and scientific simulators are examples of simulation software. Content access software. It is used to access content without editing. Common examples of content access software are web browsers and media players. Application suites. An application suite is an important type of application software. It consists of a group of applications combined to perform related functions. OpenOffice and Microsoft Office are the best examples of this type of application software. These application suites, as you know, come as bundles of applications like word processors, spreadsheets, presentation software, etc. Applications in the suite can work together or operate on each other's files. Let us now summarize what we have learned in this session. A computer is a set of resources for the movement, storage, and processing of data. The operating system is responsible for managing these resources. An operating system is a program that acts as an interface between the user and the computer hardware and controls the execution of all kinds of programs. It can perform a single operation and also multiple operations at a time. So there are many types of operating systems. Those are organized by using their working techniques. Four major categories of operating systems are batch, time-sharing, distributed, network, and real-time operating systems. Software can be roughly divided into two groups, application software and system software. Application software is all the computer software that causes the computer to perform useful tasks beyond the running of the computer itself. It can be in the form of software focused on a certain single task like word processing, spreadsheet, or playing of audio and video files. Here are a few questions for you to work out. 1. What are the key ingredients of an operating system? 2. Explain operating system and importance. 3. Discuss multiprocessing system. 4. Explain real-time system. 5. Compare freely available operating systems than commercial one. The following are some books and websites for your reference. Operating System Concepts, 8th edition by Peter B. Galvin, Abraham Silbersash, Gergag, Wiley Publication, 2009. Modern Operating Systems, 3rd edition by Andrew S. Tannenbaum, PHI Learning, 2009. Operating System Principles, 7th edition, Abraham Silbersash, Greg Gang, Peter Galvin, Wiley Publication, 2006. The Design of the Unix Operating System, 1st edition, Morris J. Bash, PHI Learning, 2012. The Complete Reference, 6th edition, Richard Peterson, Tata McGraw-Hill Education, 2007. The following are some of websites for your reference: www.guideofcomputer.blogspot.in, www.webopedia.com, www.kb.iu.edu. Thank you for watching this session. Let's meet in the next session. Until then, bye.
Health in simple traditional sense has been viewed as absence of disease. The person without any disease is considered healthy. In ecological terms, health is viewed as a dynamic equilibrium between human being and environment, and disease as small adjustment of the human being to the environment. The psychological concept defines health as health is not only biomedical concept phenomenon, but is influenced by social, psychological, cultural, economic, and political factors of the people concerned. To be more precise in defining health, let us consider the definition of health provided by World Health Organization. WHO defines health as a state of complete physical, mental, and social well-being, and not mere and integrate with each other. Longitudinally along the axis of the structurally, brain is divisible. Lobes take part only in relaying the stimulus of smell to temporal lobes of cerebral hemispheres. Now the second, that's cerebrum, or we call it as cerebral hemispheres. It's the largest part of the brain, constituting nearly 80% of the whole. Cerebrum is made up of two halves called nervous system. WHO defines health as a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. This definition covers almost all aspects of human life, such as social, economic, physical, physiological, etc. Now we can say that health does not just mean the physical well-being of the individual, but refers to the social, emotional, spiritual, and cultural well-being of the individual and of the whole community. Further, we may perceive health as maintenance of function and structure of body and its interaction with the environment.
Hello, dear students. Today we are going to discuss functional anatomy of central nervous system, autonomic nervous system, and peripheral nervous system, basic concepts of temperature regulation of body. Before delivering the lecture, let's see what the main objectives of today's lecture are. To know how the different components of human nervous system coordinate and integrate with each other. To give a precise account about the general, structural, and functional anatomy of the human nervous system. To outline different concepts about behavioral aspects of human beings associated with the nervous system. Identify the 12 cranial nerves, 31 spinal nerves, and list their functions. To have a look on how is temperature regulated in different organisms. To know the role of hypothalamus in thermoregulation. First, let's have an introduction about the nervous system. Human nervous system consists of two subsystems, that is central and peripheral nervous systems. It's a part of nervous system which runs longitudinally along the axis of the body. It's located mid-dorsally, is hollowed, and is being protected inside the axial skeleton of the body. Central nervous system consists of two parts, brain, which is inside the cranium, and spinal cord inside the vertebral column. Peripheral nervous system. It is that part of central nervous system which is made up of nerves and ganglia that come out of the nervous system and spread laterally. It consists of two types of pathways. First, afferent pathways carrying information to central nervous system. Second, efferent pathways carrying commands or responses from central nervous system, visceral nervous system. It is an involuntary part of peripheral nervous system, also called as autonomous nervous system. Regulates the activity of cardiac muscles, smooth muscles, and glands. Neuroendocrine system is a composite system consisting of a network of endocrine glands where hormone secretion is regulated and controlled by commands from central nervous system. Brain is present in the head region inside the cranium, which is a part of our skull. It is the widest and the uppermost part of central nervous system. Human brain is about 1200 to 1400 grams in weight and constitutes about 98% weight of central nervous system. Now, structure of the brain. Structurally, brain is divisible into three parts. First is forebrain, which is also known as prosencephalon. It is the front and the anterior part of the brain and is formed of three main parts. First, olfactory lobes, that's rhinencephalon. They are a pair of small, solid, club-shaped structures which occur inferior to cerebral hemispheres, so that they are visible only ventrally. Each olfactory lobe has an olfactory bulb and an olfactory tract. In lower animals, each olfactory lobe has a cavity called rhinocele, that's olfactory ventricle or first ventricle. It is absent in human beings, however. Now the functions. It's a seat of smell in lower animals, but in human beings, olfactory lobes take part only in relaying the stimulus of smell to temporal lobes of cerebral hemispheres. Now the second, that's cerebrum, or we call it as cerebral hemispheres. It's the largest part of the brain, constituting nearly 80% of the whole. Cerebrum is made up of two halves called cerebral hemispheres. The two cerebral hemispheres are separated by a deep longitudinal fissure. They are attached to each other on the inferior side by a 10 centimeter thick curved band of about 200 million myelinated nerve fibers called corpus callosum. Anterior part of corpus callosum is folded back called genome. Posterior part of corpus callosum, which is a knob-like structure called splenium. Now the third part, cerebral cortex and medulla. Gray matter forms 2 to 4 millimeter thick outer cortex of the cerebrum called cerebral cortex. It is made up of 6 layers having 10 billion pyramidal, granular, and spindle neurons, which constitute about 10% of the total neurons of the brain. There are three types of specific areas of cerebral cortex. First, sensory, which has somatic sensations, hearing, vision. Next is motor, which include muscle movements. And last is association, that is, receiving and analyzing signals from a multiple of sensory, motor, and subcortical structures. Nerve fibers are generally myelinated, so that the subcortical region appears white and opaque, which represents white matter called the cerebral medulla. Now let's move on to the midbrain, which is also known as mesencephalon. It's a small and middle part of the brain which contains groups of nerve cells scattered in white matter. A canal called iter or cerebral aqueduct connects third ventricle with fourth ventricle and is present inside the midbrain. Now midbrain has two parts, corpora quadrigemina being the first. They are 4 in number, 2 on each side as rounded swellings. Out of 4, the 2 swellings called superior colliculi or superior corpora control the visual reflexes, receiving impulses from the eyes and muscles of the head, so that eyes and head can be moved to focus an object. The rest 2 swellings, inferior colliculi or inferior corpora, controls the auditory reflexes, receiving impulses from ears and muscles of head, so that ears and head can be moved to locate and detect the source of sound. Functions of corpora quadrigemina. It controls the sight and hearing reflexes. Crura cerebri, that's cerebral peduncles. They are fibrous tracts in 2 number present inferior side of the midbrain and connects the forebrain with the hindbrain, in turn connecting third ventricle with the fourth ventricle of medulla oblongata. Now moving on to the functions. It takes part in controlling muscle tone. Finally, moving on to the hindbrain, that's also known as metencephalon. Hindbrain is composed of 3 parts. First is cerebellum, that's also known as epencephalon. It's the second largest part of brain, which lies behind the cerebrum and above the medulla oblongata. Cerebellum literally means little cerebrum, which is well developed in human beings because erect posture requires extra effort in maintenance of balance. It consists of 3 parts, 2 lateral cerebral hemispheres and middle vermis. Cerebellum consists of gray matter outside and white matter from inside. Cerebellum bears 3 pairs of bundles of myelinated nerve fibers called cerebellar peduncles, which function as communicating link between cerebellum and other parts of the brain. Now let's move to the functions. It maintains the equilibrium of the body, it moderates the voluntary movements of the brain, and controls the muscular activities like running, typing, talking, cycling, etc. It also maintains the muscle tone. Now moving on to the medulla oblongata, which is also known as myelencephalon. It's a cylindrical part of the brain that forms the hindermost part of the brain. Medulla oblongata has a fourth ventricle, which is continuous with iter in front and central canal of spinal cord behind. Posterior choroid plexus is formed by the fusion of non-nervous part of medulla oblongata and pia mater, which helps in the formation of cerebrospinal fluid. Right cerebral hemisphere controls the left side of the body and vice versa. Functions. Various involuntary movements of the body are under the control of medulla oblongata. It bears cardiac center for heartbeat regulation, a reflex center for secretion, vomiting, peristalsis, salivation, activity of alimentary canal, etc. is present inside the medulla oblongata. Medulla oblongata also bears vasoconstriction and vasodilation centers. Now, pons varolai. Pons means bridge in Latin, so it is situated in front of the cerebellum, below the midbrain and above the medulla oblongata. It consists of nerve fibers which bridge the gap between the two hemispheres of the cerebellum. Now, functions. Like the midbrain, transmits messages to and from the spinal cord and cerebrum. Respiratory center known as pneumotaxic center or shutting center is present inside the pons varolai. Cerebrospinal fluid. It's a colorless and clear fluid that bathes the interior and exterior of brain and spinal cord. It resembles blood plasma in composition, containing protein, glucose, salts, and other substances. It is secreted into the ventricles from where it circulates around the whole brain and spinal cord and is then reabsorbed into the venous sinuses of the body through the arachnoid matter. The functions. It assists in transportation of nutrients and removal of waste and toxic substances. Keeps constant internal pressure and makes central nervous system moist. Picking off oxygen from blood and supplying the same to different parts of nervous system is facilitated by this cerebrospinal fluid. Cerebrospinal fluid acts as cushion in order to protect the central nervous system from external shock. Now, unique features of the human brain. The large-sized cerebral hemispheres are the areas where the centers of activities like memory, reasoning, intelligence, etc. are located. Increased area of cerebral cortex is due to the presence of gyri in cerebral hemispheres. Absence of rhinocele or first ventricle. Presence of arbor vitae, pons varolai, and 3 brain meninges, that is, dura mater, arachnoid, and pia mater for protection. Now, the peripheral nervous system. It's the lateral part of the nervous system which connects different parts of the body with central nervous system along with their various receptors and effectors. It consists of 12 pairs of cranial nerves and 31 pairs of spinal nerves. Now first, let's discuss cranial nerves. Cranial nerves arise from the brain and comes out of the cranium through apertures called foramina. There are 12 pairs of cranial nerves in human beings which are as under. Olfactory nerves. These nerves are sensory in nature, pick up sensation of smell, and pass it to the temporal lobes of cerebral hemispheres for interpretation. Optic nerves arise from thalami of diencephalon. These are sensory in nature, pick up sensation of sight from the retina, and transfer the sensation to the temporal lobes of cerebral hemispheres for interpretations. Oculomotor nerves. They arise from floor of midbrain, innervate retina of eyes, tear glands, and ciliary muscles of eyes. The nerves are motor in nature and control the rotation of eyeballs, size of pupil, and accommodation of eye. Pathetic or trochlear. The most slender and the smallest of all the cranial nerves. These nerves arise from the midbrain, help in movement of eyeballs, and are motor in origin. Trigeminal nerves. These arise from ventral surface of pons varolai, bear trigeminal ganglion at its base, and it then bifurcates into 3 bronchs. It's the largest cranial nerve, also known as the dentist nerve. The 3 bronchs are as under. Ophthalmic, which is sensory nerve supplying the lacrimal glands, conjunctiva of the eyes, eyelids, forehead, anterior part of the scalp, and mucous membrane of the nose. Maxillary. These are the sensory nerves which are distributed to the lower eyelids, upper lip, upper teeth, and cheeks. Mandibular. It's mixed in nature. It controls the movement of lower jaw and tongue, hence helping in mastication of food. Going back to the cranial nerves, that's abducens nerves. Originate from floor of pons, are motor in origin and helpful in movement of eyeballs. Facial nerve. The nerves are mixed in nature and control the facial expression with the help of mimetic muscles. These nerves control secretion of salivary glands, tear glands, and sense of taste from tongue except bitter. Auditory nerves. These originate from sides of pons and consist of 2 branches. First is vestibular branch. It helps in maintaining the balance. Second is cochlear. It helps in hearing. Glossopharyngeal nerves. These originate from sides of medulla oblongata and helps in perceiving taste, salivation, and swallowing. They are mixed nerves. Vagus nerve. It's pneumatogastric nerve. They arise from sides of medulla oblongata and control the functioning of internal visceral organs like muscles of larynx, heart, blood vessels, esophagus, stomach, intestines, and pancreas. They are mixed cranial nerves. Spinal accessory nerves. These nerves cause movements of neck, shoulder, and visceral reflexes. They are motor in nature. Hypoglossal nerves. They control the movement of tongue and are motor in origin. Spinal nerves. These nerves develop from the spinal cord and supply all parts of the body not covered by the cranial nerves. These nerves come out of the vertebral column through intervertebral foramina. They're all mixed nerves. Spinal nerves are divided into 31 pairs. 31 pairs of spinal nerves are classified into 5 groups. Cervical, which are 8 pairs. Thoracic, 12 pairs. Lumbar, 5 pairs. Sacral, 5 pairs. And finally coccygeal, which is only 1 pair. Now we will discuss autonomic nervous system. It's a self-governed system of peripheral motor nerve fibers and ganglia, which control involuntary activities of various visceral organs and glands to stimulate, accelerate, and stop their functions without directly consulting the will. Also known as visceral nervous system, it has 2 opposing divisions, sympathetic and parasympathetic divisions. Sympathetic nervous system, also called as thoracolumbar outflow, it originates from rami, communicates of all thoracic and first 3 lumbar spinal nerves. It consists of chain of different types of ganglia. First, chain of lateral ganglia. There are 2 ganglionatic chains originating from neck to pelvis on either side of the vertebral column and each bearing 21 sympathetic lateral ganglia. Second, preganglionic fibers. The nerve fibers arise from lateral horns but come out through ventral roots separating in the region of bifurcation of spinal nerves and are cholinergic in origin. Third, collateral or prevertebral ganglia. These are long preganglionic nerve fibers called symplectic nerve fibers come out of lateral ganglia instead of ending in them. Fourth, postganglionic fibers. The nerve fibers innervate involuntary muscles, glands, and different body parts or visceral tissues. The nerve fibers or adrenergic provide excitation through secretion of sympathicin. However, postganglionic fibers innervating sweat glands are cholinergic. Now the functions. It coordinates the activities of a number of body organs. It takes active role in the activation of adrenal glands to meet an emergency, constricts peripheral blood vessels, and increases heartbeat as well as blood pressure. It involves in erection of hair during emergency, dilation of pupil, and relaxation of urinary bladder. It also helps in temporary decrease in peristalsis of gut, small intestine, and inhibits digestive gland secretions. Now moving on to parasympathetic nervous system. It arises from 3rd, 7th, 9th, 10th, 11th cranial nerves and 2nd, 3rd, and 4th sacral spinal nerves, hence also known as craniosacral outflow. As a part of autonomous nervous system, it helps in performing daily activities of various organs, preventing their overexploitation and conserving body heat. It consists of a chain of 4 different types of ganglion fibers. These are parasympathetic ganglia. They are separate ganglia which occur in close association with the visceral organs and glands. There are additional ganglia which occur in head, ciliary from 3rd cranial, sphenopalatine, and submaxillary from 7th cranial. Second is preganglionic fibers. The nerve fibers are cholinergic, developed from 3rd, 7th, 9th, 10th, and 11th, and 2nd, 3rd, and 4th sacral spinal nerves. Preganglionic fibers of 3rd, 7th, and 9th cranial nerves remain restricted to head region, whereas those of 10th and 11th cranial nerves reach up to thoracic and number of abdominal organs, while the ones from sacral spinal nerves pass onto large intestine, reproductive organs, and other parts of the lower body. Third, postganglionic fibers. They are very short, lie very near to visceral organs and other areas of innervations. The nerve fibers are cholinergic. Functions. It increases the peristalsis in intestine, reduces the blood pressure, and hence slowing down the rate of heartbeat. It promotes the secretion of digestive glands as well as salivation. Now, let's move on to the thermoregulation or temperature homeostasis. One of the most important examples of homeostasis is the regulation of body temperature. Not all animals can do this physiologically. Animals that maintain a fairly constant body temperature, for example birds and mammals, are called endotherms, while those that have a variable body temperature, all other taxa, are called ectotherms. Endotherms normally maintain their body temperatures at around 35 to 40 degrees Celsius, so or sometimes called warm-blooded animals. But in fact, ectothermic animals can also have very warm blood during the day by basking in the sun or by extended muscle activity, for example, bumblebees and tuna. The difference between the two groups is thus that endothermic animals use internal corrective mechanisms, whilst ectotherms use behavioral mechanisms. For example, lying in the sun when cold, moving into the shade when hot. Such mechanisms can be very effective, particularly when coupled with internal mechanisms to ensure that the temperature of the blood going to the vital organs like brain and heart is kept constant. In humans, body temperature is controlled by the thermoregulatory center in the hypothalamus. It receives input from 2 sets of thermoreceptors. Receptors in the hypothalamus itself monitor the temperature of the blood as it passes through the brain, that's core temperature. And the receptors in the skin, especially on the trunk, monitor the external temperature. Both sets of information are needed so that the body can make appropriate adjustments. The thermoregulatory center sends impulses to several different effectors to adjust body temperature. Our first response to encountering hotter or colder condition is voluntary. If too hot, we may decide to take some clothes off or to move into the shade. When too cold, we put extra clothes on or turn the heating up. It is only when these responses are not enough that the thermoregulatory center is stimulated. This is a part of autonomic nervous system, so the various responses are all involuntary. When we get too hot, the heat loss center in the hypothalamus is stimulated. When we get too cold, it is the heat conservation center of hypothalamus which is stimulated. Thanks. Well, I really hope that you have understood the lecture.
The Fabaceae are traditionally classified into 3 subfamilies: Caesalpinoideae, Mimosoideae, and Faboideae. Faboideae is also known as Papilionoideae. Many authors have advocated raising these subfamilies to the level of family. Some even treat them so. Now, the Caesalpinoideae, it's a subfamily of Fabaceae. Flowers in this subfamily are generally zygomorphic, with usually 5 or 10 free stamens. Staminodes are present in some species, and a corolla, which is imbricate in bud, with typically 5 distinct petals, sometimes reduced or lacking. The posterior median petal is inner to the two lateral petals. The next subfamily is Mimosoideae. Flowers generally act of 5 free or basally fused petals which are valvate in bud. A hypanthium is sometimes present with usually numerous distinct or basally fused stamens. Now a Forboideae, which is also known as a Papilionoideae. Leaves are usually pinnate, compound with a pulvinate base. Flowers are zygomorphic, sepals united with odd sepal anterior, corolla imbricated bud, papilionaceous, that is, with 5 petals consisting of a large median, usually posterior petal called the standard, banner or vexillum, 2 lateral lanceolate and curved petals called wing petals or alae, and 2 anterior and distally fused innermost petals called keel petals or carina. All the petals have an attenuate base called the claw. The flowers are rhizopinnate in some species like Clitoria, in which the banner is anterior in position. Stamens 10, usually diadelphous or monadelphous, carpel 1, ovary superior.
Dear students, today I am going to deliver a lecture on one of the pteridophytic plant known as Marsilea. Marsilea, a pteridophytic genus commonly known as water fern, usually grows in mud, shallow ponds and pools with the leaves floating on the surface of water. Its species are ubiquitous, that means they are distributed throughout the world but are more common in tropical Africa and Australia. The genus is represented world over by 53 living and 10 fossil species. In India, Marsilea is represented by 9 species. Of these 9 species, Marsilea minuta and Marsilea quadrifolia are most common and widely distributed one. Then we will discuss its systematic position. The Marsilea belong to kingdom Plantae, division Pteridophyta, subdivision Pteropsida, class Phelicophyta, order Marsiales, family Marsiaceae, and genus is Marsilea. Then we will discuss its plant body. The plant body of Marsilea is sporophytic, having diploid chromosome number in its somatic cells. The sporophyte is differentiated into rhizome, roots and leaves. We will first discuss about the rhizome. The stem is long and slender. It either creeps on the surface like stolons or slightly below the surface of the soil, just like rhizome. It is grow extensively and is branched. The stem is divisible into distinct nodes and internodes. The internodes are long in case of hydrophytic species, that means those species which grow in water bodies, and they are short in subterrestrial or xerophytic species. Then we will discuss about the root. The primary root formed on the stem, it is short-lived and it is replaced by adventitious roots which arise gradually at the nodes on the underside of the stem. Then it is leaves. The leaves arise from the upper side of stem and are arranged in 2 alternate rows. They are long, petiolated and compound. The leaf lamina is usually divided into 4 leaflets of the same size. They spring from tip of the petiole so that the leaf apparently looks like quadrifoliate. At the base of the petiole, many bean-shaped or oval and stalked structures arise, which are called as spore corps. Then anatomy of the Marsilea. When we cut the transverse section of the Marsilea, it shows certain distinguishing features. First, we will discuss about the rhizome. When we cut the transverse section of the rhizome, it shows certain features, like the outer covering is called as epidermis. It is single-layered, made up of compactly arranged thick-walled cells. Then epidermis is followed by cortex, which is differentiated into three regions in case of Marsilea, that is outer cortex, middle cortex and inner cortex. The outer cortex is Ehrenkaimers. It is made up of several cells in thickness having large intercellular spaces. These Ehrenkaimers cortex, they help the plant to float on the surface of water. Then it is followed by middle cortex, which consists of sclerenchymal tissue, and then inner cortex is solid tissue made up of several cells in thickness. Then the vascular bundle, which is present in the center, it is saphenostele. It is limited externally and internally by endodermis, hence called outer endodermis and inner endodermis respectively. And the saphenostele in case of Marsilea is medullated, which means it has a pith at the center of the stem. The xylem is in the form of ring and phloem is present on both sides of the xylem. Such a stele in which phloem is present on both sides of xylem is called amphipolic saphenostele. Then we discuss transverse section of the petiole, means the stalk of the leaf. It shows single-layered epidermis made up of rectangular cells. The outer cortex consists of 5 layers of thin-walled cells. Middle cortex is Ehrenkaimers, consists of large number of air chambers, while the inner cortex is solid, compact tissue of several cells deep. In case of pteridophytes, the vascular bundle is called as setile. It is covered externally by single-layered distinct endodermis. It is triangular in outline, lies in the center and has a single vascular bundle. The xylem that is present in the center is V-shaped with openings towards the axis. Then when we cut the transverse section of the leaflet, it consists of upper and lower epidermis.